Confirming the truth of confirmation bias. Confirmation bias is the tendency of people to focus on evidence that confirms their existing views and to ignore or discount information that may challenge those views. For all their reputation as dispassionate sifters of data, scientists often fall easy prey to this bias, repeatedly rejecting experiments that come to the wrong conclusions. The history of science is full of cases in which scientists carry out an experiment to prove their theory, but if the results come back disagreeing, instead of rethinking the whole theory, they suspect the experimental setup. Some great scientific discoveries arose through such behavior, but also many erroneous ideas and theories were perpetuated long after they should have been abandoned. If the problem of confirmation bias sounds rather abstract, consider this example. Mind-boggling sums are directed at developing drugs today that are supposed to help cure illnesses, and the scientists are often given the task of proving that the drugs really work. However, if the studies find that they don't work, neither the scientists nor the manufacturers benefit. Therefore, they tend to repeat the studies until they get a more positive result. This one is then carried forward. As a result, zillions of zlotys are spent on remedies that don't really work and may actually be harmful. Politicians getting the results they need. Politicians are suckers for confirmation bias. Take this example from London in the UK. In 2023, the mayor needed evidence to justify extending a traffic zone from the very center of the city to all the suburbs. The zone charged anyone who drove in it unless they were in electric cars. It had made lots of money for the mayor's cause, but the argument offered for extending it was to improve air quality and save children's lives. So, to support the policy, the mayor produced scientific evidence that showed that, in parts of the city, air quality was still dangerously poor. So the mayor of London had a policy, and he had evidence for it. Case closed. Or was it? The detail of the research was that the places in which air quality was dangerously low were in the existing zone. The measurements in the suburbs showed they already had better air quality and did not justify special rules at all. Maybe the policy was good, maybe, but certainly not for the reason offered. So-called egocentric biases, distortions due to people having an inflated opinion of their own work or importance, for example, naturally lead to other sorts of biases. Argument from authority, where someone assumes that they must be right because they're confident that they know more than their opponents on certain topics. Ad hominem, or directed at the person arguments, where the views of others are dismissed out of hand, perhaps in a condescending or even insulting manner. This bias may lead people to errors in their recall or selection of facts. Who does the dishes? It's always me. Argumentative self-control and critical thinking. Problems like these mean that critical thinkers also need to take a course in what's sometimes called argumentative self-control. This involves developing a psychological understanding of what makes people tick, alongside a logical understanding of the structure of arguments. A good place to start is with some great tips prepared by two Dutch professors, Frans van Imeren and Rob Grotendorst, as what they call a code of conduct for reasonable discussions. These appear in a book, alarmingly called Advances in Pragmadialectics, 2002, where they set out their 10 commandments to guide anyone in a debate. Here's my take on their best 4 ideas. The others become rather technical and even repeat the same broad points. Therefore, to explain your approach to argumentative self-control, you can, if you like, say that you're following Martin Cohen's 4 Commandments, though it doesn't have a great ring, I admit. Tip. Rule 1. Don't stop your opponent from advancing a new position or challenging your position. The authors call this the Freedom Commandment, and it underpins many of the others. Rule 2. Both sides must defend and justify their positions when asked to. Rule 3. Don't attack positions that no one has put forward, no matter how much fun it is and how clever it makes you look. Rule 4. Don't use anything except arguments to advance your position. For example, don't appeal to people's sentiments, let alone their prejudices or fears. Rules for arguments are all very well, of course, and few people disagree with the general principles. But arguments in the real world aren't so easily sorted out. After all, they often happen because people make genuine mistakes or have been misled by some erroneous information, such as something they heard on the radio or read in the newspaper or in Wikipedia. Add in distortions caused by strong emotional attachments, and you have a rule book that isn't really sufficient for sorting out many arguments. Remember, above all, conscious efforts to observe the rules of argumentation are rarely sufficient to prevent honest mistakes. It's only logically consistent, Captain. Practical wisdom is virtuous. The ability to recognize salient facts, open-mindedness in collecting and appraising evidence, fairness in evaluating the arguments of others, and so on, all look pretty useful and should help avoid mistakes in life. Funnily enough, the list of good instincts looks very like Aristotle's ancient intellectual virtues, written over 2,000 years ago. For background, see the nearby sidebar, Getting Practical with Aristotle. Crucial to this section is Aristotle's practical wisdom, which he says is a virtue and not a technical skill. What Aristotle is primarily concerned with in his analysis of practical wisdom is things that change and have direct implications for how humans live their lives alongside other people. It is the interface between theory and practice. Think politics, if you like. Practical wisdom deals with change and variety. Thus, it's the part of the soul that forms needed opinions. Aristotle's big idea is that the character, ethos in ancient Greek, of the arguer is crucial. Indeed, he says that someone who produces good arguments both impresses and convinces because we feel reassured about their character. Someone who produces bad arguments we begin to suspect is a rogue. Aristotle offers the example of Pericles, a Greek politician and general, saying that he demonstrated how good arguments and good character went hand in hand. Pericles was famous for his calmness and self-control, and also had a populist touch. Under him, the poor were even allowed to watch theatrical plays without paying. During one public debate, he trounced a powerful opponent called Thucydides simply by the strength of his arguments. Afterwards, those watching broke into applause, and Thucydides was obliged to slink off into the countryside. Another virtuous habit useful for anyone involved in an argument is the ability to contemplate potential objections and alternative views. Doing so offsets the twofold tendency of humans to overlook what contradicts their existing beliefs and views, and to rest comfortably on sources confirming their biases. Tip. The English philosopher John Stuart Mill expressed this attribute plainly in On Liberty, 1859. He states that playing devil's advocate is the duty of all thinkers, that is, to throw themselves into the mental position of those who think differently. If they don't, even if they're well-educated, expert arguers and their conclusion is right, they don't know why they're right because they haven't considered the arguments fully, deeply, equally, and impartially. Getting practical with Aristotle. Aristotle's tips appear in a section of his Nicomachean Ethics, where he identifies two parts of the soul, one irrational and the other rational, that grasps a rule or principle. He subdivides the rational category again. Now one part studies the eternal truths of science and mathematics, and the other, which Aristotle calls the calculated part, deals with the practical matters of human life. Aristotle's influence can be seen centuries later, echoed by the French philosopher Montaigne, when he says that developing the ability to argue soundly and to spot bad arguments is so fundamental that once learned, the skills become a sort of second nature. In their book, Logical Self-Defense, 2006, Ralph Henry Johnson and J. Anthony Blair see this problem as arising because the act of reasoning is rarely carried out in a situation that lacks an emotional dimension. That is, personal interests and involvements often distort the way people treat information and the way they argue, and emotional commitments make it harder to look at an issue from someone else's point of view. Exploring different types of intelligence, emotions, and creativity. This section looks at two important but much neglected kinds of intelligence, the emotional and the creative kinds. Did you hear about IBM's powerful computer, the one that outfoxed the world's top chess masters? Well, now it's planning to develop these intelligences too, so pay attention to this section. Thinking emotionally for success. In his research, Daniel Goleman found that although the qualities conventionally associated with leadership, intelligence, determination, vision, are part of the recipe for success, on their own, they aren't enough. The most successful people, he says, have a different kind of intelligence from the ones schools normally harp on about: emotional intelligence. The good news is, Goleman believes that these skills can be developed. They aren't fixed at birth. 5 million people, yes, 5 million, have bought his book, so it's obviously a rentable business. Critical readers should note that Goleman isn't an academic as such. For years, he was a science correspondent for the influential newspaper, The New York Times. Thinking about what other people are thinking. Emotional intelligence. According to psychologist Daniel Goleman, who popularized the term with his 1995 book, Emotional Intelligence: Why It Can Matter More Than IQ, emotional intelligence is a mix of self-awareness coupled with the ability to manage yourself, motivation, and empathy. Good leaders have social skills, in short. He contrasts it with conventional intelligence. For example, the ability to understand a complicated comment, what psychologists call threshold skills. You have to have them, but it's what comes afterwards that makes you successful or not. Emotional intelligence skills. Goleman suggests that emotions play a much greater role in thought, decision-making, and individual success than is commonly acknowledged. Tip. He argues that the skills of emotional intelligence, which he sums up as self-awareness, altruism, personal motivation, empathy, and the ability to love and be loved, are the key to success in life. Whereas other psychologists, For example, see the views of Daniel Kahneman in Chapter 2, want people to ignore their instincts and be more rational. Goleman wants them to tune in to their intuitions and trust their gut feelings. Check out the nearby sidebar, Thinking Emotionally for Success, for more on Goleman. Within the family, with friends, and in the workplace, emotional intelligence, some people call it EQ, for emotional quotient, to contrast it with intelligence quotient, or IQ, means being able to listen to, predict, and understand other people, and to know the right words to say. Tip. Here are 4 tips for raising your EQ. Spot emotions. Be aware of other people's emotions. Try to notice and read nonverbal signals such as body language and facial expressions in those around you. Realize that how a leader, teacher, or parent makes people feel plays a large role in their level of motivation and commitment. Reason with your emotions. Use your emotions to guide your thinking, such as to help you prioritize. A common error is to give too high a priority to trivial things that are urgent and neglect important things that don't have an obvious deadline. Using your EQ can counteract this tendency. Understand emotions. Emotions can conceal a wide range of causes. For example, if someone is getting angry, it may be because of what you've just done or are currently doing, which may trigger a defensive response from you. But it may also be because they just had some bad news, say a speeding ticket on the way to work, or maybe they're just overtired. In a famous book by Fyodor Dostoevsky called Crime and Punishment, the detective Porfiry Petrovich displays great emotional intelligence and empathy in his investigation of a murderer, Rodion Raskolnikov, because he sees him as a potentially great man deceived by too many new and radical ideas. And this long before the Internet. Indeed, during his final interrogation, Petrovich specifically gives Raskolnikov some more time to confess, because he sees it as a first step in the process of later rehabilitation into a useful member of society. Handle your emotions. The ability to do this is the final key aspect of emotional intelligence. For example, an athlete may be tempted to perform a celebratory trick in the last lap and maybe lose their focus and the race. This actually happened at the 2006 Winter Olympics when snowboarder Lindsay Jacobellis made the mistake of celebrating her gold medal before actually having won it and ended up with her face in the snow. A brief history of emotional intelligence. 1930s. Edward Thorndike describes the concept of social intelligence as the ability to get along with other people. 1940s. David Wexler suggests that affective components of intelligence, that is, the ability to deal with moods and feelings, may be essential to success in life. 1975. Howard Gardner publishes The Shattered Mind, which highlights the concept of multiple intelligences, which are the different ways people interpret and interact with their surroundings. Conventionally, intelligence is thought of as interactions via things such as language and logical mathematical analysis, but there are many other ways, too, such as spatial representation, musical thinking, kinesthetic intelligence to do with the sense of shape and touch, and varieties of emotional intelligence. 1995. The concept of emotional intelligence is popularized after publication of Daniel Goleman's book, Emotional Intelligence: Why It Can Matter More Than IQ. Perhaps the key point in the book is the importance of self-awareness. Hey, that was Socrates' point too, more than 2,000 years ago. EQ, not IQ. Unlike IQ, which is gauged by highly standardized tests, such as the ones from Stanford Binet, EQ doesn't lend itself to any single numerical measure. After all, by definition, it's a complex, multifaceted quality representing such intangibles as self-awareness, empathy, persistence, and social skills. Some aspects can, however, be quantified, such as optimism. According to some psychologists, how people respond to setbacks, optimistically or pessimistically, is an indicator of how well they succeed in life. Remember, the good news is that emotional intelligence involves skills you can learn, such as ambition to achieve and emotional self-control, both of which build on underlying EQ skills, such as self-management. This ability to manage yourself, to have self-awareness and self-regulation, is the key to managing others. For employees, how a leader or manager makes them feel plays a large role in their level of motivation. For customers and clients, how they feel about their interactions with the people in an organization often decides their feelings about the place as a whole. Tip: one way to boost your self-awareness is to undergo an evaluation by people you know well and trust to speak intelligently about your emotional characteristics and competencies. There are some nice and quick tests on the internet, for example, which ask things like, do you regularly help people by pointing out their errors and faults? Finding out about fuzzy thinking and creativity. Being logical is good for some kinds of problems, and being emotionally in tune is useful for many more. But plenty of situations require something rather harder to pin down: creative insight. In these kinds of situations, lots of possible answers can apply. In a sense, anything goes, and the more the merrier, too. It's not just at advertising agencies looking for new marketing strategies, or during design consultancy brainstorm sessions that benefits from creative insight arise, but so too do hard-nosed economists trying to work out how to reboot the economy, and even doctors wondering why so many people seem to be getting colds. Yet, in many situations, people still want to end up with something that commands wide acceptance, rather than just their own idiosyncratic opinion or view. In such cases, creative thinkers have to be prepared to risk losing arguments and admit that they've gone up blind alleyways. Warning: creativity is unstructured and unpredictable, which can be difficult if you're more used to analytical and logical approaches. With creative thinking, it's important to be able to cope with risk, confusion, disorder, and feeling that you're not progressing quickly. For example, many important breakthroughs in science and innovation have resulted from dreams or daydreams when the innovator wasn't trying so hard to find the answer. The rewards of creativity are golden, and not just in the arts. Tip: nurture your creative side. Start by jotting down any inspirations, good or bad. You can weed them down later. Remember, ideas can also slip away very easily. See also Chapter 7. Answers to Chapter 4's exercises. Here are my answers to this chapter's test. Feedback on the Critical Thinking Skills Test. 1. Brain teasers. The point of this little teaser is that the important information is present in the dull-looking line about the windows all facing south. Thus, the house must be at the North Pole, so the furry animal is white, a polar bear. It's easy, but unwise, to overlook the dull. 2. Word pictures. Each picture is made up of words, but also represents a common saying. What are they? A. Split-second decision. B. One after another. C. Up in arms. D. Downward spiral. 3. Spot the fallacy. Slippery slope arguments are ones where someone plays on the fact that often the line between two things is hard to draw, but, nonetheless, there is a generally accepted difference to be respected. Begging the question, or circular arguments, assume at the outset what is supposed to be demonstrated later on. Straw man arguments pose ridiculous examples only to easily knock them down later. Non sequiturs, from the Latin, are claims that do not actually follow in any logical sense. Ad hominem arguments, again from the Latin, are those that attack the person making the claim rather than deal with what they are saying. You can legitimately say that this argument contains many fallacies, but I claim that the straw man is the most relevant one to note. No vegetarians argue this, and so the claim that they do is, well, made of straw. The answer to the second part, spot another fallacy, is begging the question. In other words, the explanation being used to back up the point relies on assumptions made at the outset. 4. Good argument. The third response, C, provides what I would call the most reasoned response. Don't be confused or impressed by strong statements either in favor or against a point of view. The reasons given and the arguments offered are what matter. 5. Typecasting. I'd vote for D, Jenny and her new car. But honestly, you can make a case for most of them being rooted in irrationality. These questions are popular in critical thinking tests, but they're really rather subjective. 6. More typecasting. Well, I think you can guess that A is the correct answer in business circles. After all, she may not know about marketing, but she does presumably know what's good about her designs. But in the real world, I have sympathy for the directness of response B, because to me, the artistic mindset should not be made too subservient to business. In the real world, the sneaky tactic of the third option I suspect will work pretty well for the employee too, but it's definitely wrong here. 7. Business skills. The correct answer is C. Amazed? But that's the view of most business skills authorities who offer such questions. In the real world, I suspect answer A will get you further. 8. Time management. I think the correct answer is to prioritize, which I didn't put in here. Call it a trick question. 9. Justice for TV watchers. This is a very confusing question. It seems to be about ability to pay, but in fact it isn't. Literally, the argument is that those who use a service most should pay most. If poor people watch lots of TV, they should pay most. The only choice here putting forth that argument is C, which seems to be saying the opposite. Rich people should pay a surcharge on their houses so as to help poor people who maybe don't have a home at all. It would be easy to misread the question and support D. Television channels should be paid for by general taxation, so that the richer you are, the more you pay. I'd call this almost a trick question. 10. Car rentals. It's 226 miles. It took me absolutely ages to work out, and indeed, in the first printing of the book, I still had it wrong. Sorry about that, readers. Proof that it pays to be a critical reader. The way I did it was to turn it into an equation, and this should read something like, rounding up the cost of renting from $19.99 to $20, 20 plus, open parentheses, number of miles minus 100, close parentheses, times 1 equals 100 plus, open parentheses, number of miles times 0.2, close parentheses. Bonus question: the riddle of the old-fashioned brew. I can see two ways to solve this one, a long way and a short way. The long way is to create two simultaneous equations. The unknown is the original number of people. Call it n. Pre-grandma. N spoons plus 1 spoon equals 1 packet per week of tea. Post-grandma. N spoons plus 1 spoon plus 1 spoon equals 1.25 packets per week of tea. Multiplying the two equations to make them both equal to 5 packets per week then allows the comparison 5n plus 5 equals 4n plus 8. This reduces to n equals 3. So there were 3 people drinking tea originally, and Grandma makes the 4th. The short, more elegant way to approach this is to argue that we're told tea consumption is up 25%, or 1 extra box after every 4 weeks, and that Grandma takes 1 spoon of tea. Isn't the trick then that 1 spoon of tea should also correspond to 4 earlier ones by the same proportions, and given that there was the spoon for the pot, then there were 3 original tea drinkers. Isn't that all we need? The tea one is even simpler if you think of just 1 huge pot of tea per month. You put 4 packets in, 1 per person and 1 for the pot. When Grandma joins in next month, that's 5 packets, 1 for each person and 1 for the pot. I have seen people discussing questions like this one on the internet. They sometimes get the right answer, but for the wrong reasons, which may be okay in a test, but usually not in real life. One person who managed to get the right result stated confidently that the spoon for the pot was completely irrelevant. But of course, it is not. Neglect that, and you'll have an awful cup of tea. Part 2. Developing your critical thinking skills. In this part, solving puzzles and reasoning by analogy. Drawing on graphical tools for thinking. Learning how to construct knowledge. Chapter 5. Critical thinking is like solving puzzles. Reasoning by analogy. In this chapter, creating compelling comparisons. Spotting dodgy analogies. Carrying out thought experiments. With this chapter's title, I don't mean to imply that critical thinking is literally another term for solving puzzles, but instead that the two actions share areas of similarity. The connection is that solving puzzles, like critical thinking, involves the use of insight, of creative imagination, the tool that produces that famous eureka moment. See the nearby sidebar, Eureka. If critical thinking is using the same kinds of hidden abilities as puzzle solving, then it's clearly doing something right. Brilliant insights are the stuff of legend, whether they're in science, business, or the arts. No one really knows the secret to obtaining them, despite the huge number of books offering tips. But certain strategies do seem to be related, and I take a look at some of them in this chapter. I guide you through the world of analogies, like the one in this chapter's title, discuss how to make effective comparisons and how to recognize false ones, and describe some thought experiments that employ analogies and bring people towards thinking critically. Investigating inventiveness and using your imagination. Creative insight is linked to the imagination and to people's inbuilt ability to make connections between two quite different things. Take the skills of the imagination. People aren't taught them very often. They're always the poor cousin to learning the 3 R's: reading, writing, and arithmetic. When I went to school, we did do a little bit of art, and reading and writing at least included making up stories. But nowadays, because governments are focusing on making education more business-friendly, art is often reduced to being part of computer studies, and writing is all about spelling and grammar. Remember, new ideas don't come from following routinized methods. Powerful though such tools can be in areas where solutions and strategies are already known. Eureka. Eureka isn't an expression indicating that someone is a bit smelly. Eureka. It's the Greek word for "I've found it." The word is forever linked to the ancient Greek mathematician Archimedes, who's supposed to have exclaimed "Eureka" when sitting in his bath one day. Was it because the water was too hot? Had he just located the soap? Not at all. Archimedes had just found the solution to the tricky mathematical problem of how to measure the volume of an irregularly shaped solid. Even stating the problem makes me feel giddy. While having a relaxing soak, Archimedes noticed that after he sat in his tub, the level of the water rose. The clever bit was the realization that if he stepped out of his bath and placed one of those irregular objects in it, the water would rise again. In other words, he'd found an easy, practical way to measure volumes of objects. Eureka, indeed. In this section, you can find out why analogies are an essential element in thinking, and why they are often at the heart of creative insights. The explanation involves the very workings of language. In other words, I will be trying to use the thing to be explained in order to explain it. But bear with me, some of the cleverest people around say that this skill is the gold standard for new and original ideas. Remember, categorizing is an absolutely fundamental human ability, the basis for language and how people divide up the world into bits and make sense of it. But how come people can tell tables and chairs apart, even though they often both have 4 legs and are made of wood? Or, more precisely, how do people decide which similarities matter? Standardized intelligence tests, such as the one I'm going to present in a moment, often try to measure people's ability to categorize. But such tests really only measure a very narrow part of the skill, the logical part. Researchers have found that in real life, categorizing is much more complicated than that, involving many judgments and assumptions, most of which people aren't consciously aware of. Box 'em up. Think of a category, or box, to which all items in each line of the following list belong: Jupiter, Saturn, Mars, Pluto, Venus. 3 o'clock, tomorrow, the Stone Age, Wednesday, 1964. Mumps, tonsillitis, Asperger's syndrome, acute nasopharyngitis, fractured hip. Minim, deed, tenet, God's dog, too hot to hoot. Okay, that was pretty easy, but now try to spot the odd one out each time. You can find the answers in the later section, Answers to Chapter 5's exercises. Understanding the importance of analogies to creativity. Some researchers, looking at the way minds work and how people seem to think, place the human ability to see analogies center stage and credit it with all the greatest insights and inventions of history. Anyone who has taken a critical thinking test will certainly have been faced with questions like this. Dog is to rabbit as cat is to... The answer here is mouse. Why? Because mice and rabbits are both furry and cute? Not at all. Because there is an important relationship implied between dogs and rabbits. The former chases the latter. The same thing with cats and mice. It's also the principle being sought in missing number questions, like 2, 3, 5, 8. Critical thinking tests recognize the importance of this kind of intuition, the ability to pick out of a huge range of possible answers the most relevant ideas. The skill is twofold. First of all, being able to consider possibilities, which is a skill of the imagination, and secondly, the ability to analyze and select. Call it the librarian skill, the ability to put things into categories. Watching your language. The great difference between human beings and the rest of nature is that humans have this incredible tool, language, that enables them not only to communicate, but to create and manipulate models of the world in their minds. A critical thinker does precisely this whenever they try to tackle an issue. And the building blocks of these conceptual models are words. So to understand and hopefully improve how your mind works, it really is useful to go back a step and think about how language works. Contrary to popular opinion, reinforced by things such as dictionaries, definitions of words are actually pretty blurry, not so much fixed as fuzzy. Sometimes they can completely reverse their meaning, too. Originally, the word nice meant something like silly, and the word silly meant something like, well, nice. Remember, ordinary words don't just have 2 or 3 meanings, but an unlimited number. Ask Humpty Dumpty. In Through the Looking Glass, the famous children's book by Lewis Carroll, Humpty tells Alice, "When I use a word, it means just what I choose it to mean, neither more nor less." Alice disagrees, disputing whether anyone can make words mean so many different things. Humpty's reply is revealing. The question is, which is to be master? That's all. In reality, some people are more influential than others in deciding what words mean, such as the people who write dictionaries. But bloggers with millions of followers can change the way words are used, too. The fact that we forget that the meanings of words often change over time is really the fault of the philosophers who, ever since Plato, have insisted that every word, whether for grand things such as beauty and truth, or humdrum things like chairs and teapots, has one very precise meaning, if only humans can find it. Mind you, it certainly helps to think about what all chairs, for example, have in common. Is it 4 legs? Flowery cushions? And this instinctive ability to put things in the right category requires you to strip away the inessential qualities of things in search of an underlying core. Of course, something could be a chair, even without a flowery cushion. But what is really important to make something into a sofa? I can't answer that. And 2,000 or so years ago, Plato flailed about ineffectually too, trying to nail the issue. The reality is that words are not used tidily. They are used loosely and allegorically. People can, and do, use everyday concepts such as chair, teapot, or even blue, as well as apparently tightly defined things such as triangles or the number 3, in more than one way. 1 word, 2 jobs. Most words do one job in a sentence, but not all of them. Some words do too. The way some words can modify or govern other words in a sentence illustrates how metaphors and analogies are built into language. Here's a good word for Scrabble enthusiasts: zeugma. A zeugma is a sentence such as Charles Dickens's remark about Miss Bolo, that she went straight home in a flood of tears and a sedan chair. One word, in, is made to do two jobs. When a word like in has different shades of meaning, you know you have to look at the sentence very, very carefully. Zeugmas are similar to anaphora, another venerable medieval term referring to the way words can refer back to terms used earlier. Both of these originally came from ancient Greece, where zeugma meant literally a joining or a kind of bridge, while anaphora was a clay pot useful for carrying something, say water or wine. That of these is an anaphora. The fact that medieval scholars adapted the terms to talk about how we use words shows just how long the history of philosophy of language is. Even that granddaddy of philosophers, Plato, used many analogies, although he sometimes seems to have felt a bit guilty about doing so. See the nearby sidebar, Philosophers Arguing About Analogies, for more examples. On the other hand, historically, many English and American philosophers have seen their job as eliminating linguistic ambiguities and doing away with imprecise, fuzzy thinking. Professors tend to see their job like this. Two great 17th century English philosophers, John Locke and Thomas Hobbes, prided themselves on the sort of clear, logical thinking that critical thinking at its best is all about. They directly blamed imprecise language for much of the world's ills. Hobbes wrote disapprovingly, "Metaphors and senseless and ambiguous words are like ignes fatui, and reasoning upon them is wandering amongst innumerable absurdities." Ignes fatui is literally a phosphorescent light that hovers over swampy ground at night. So Hobbes is using an analogy himself. For Hobbes, the line of reasoning, the mental discourse, is true, but problems arise when people try to communicate their ideas, and with the translation of thoughts into words. Note here the recognition that conceptual imprecision allows for grand creative leaps. As Douglas Hofstadter and Emmanuel Sanders say in a book called Surfaces and Essences, Basic, 2013, the history of mathematics and physics consists of a series of snowballing analogies. Snowballing being a metaphor intended to indicate that the use of analogies steadily increases as old analogies get used to form new and grander ones. They note that the great French mathematician, Henri Poincaré, was a keen thought experimenter and often used analogies to help him along the route towards mathematical discovery. And the same was true of Einstein. Seeing how words play tricks. Even when you try to express yourself very simply, you often find that words can confuse and mislead. Sometimes what you mean by a word may not be what someone listening understands by the same word. Take happiness, for example. It is such an important idea that it is often claimed to be a human right: life, liberty, and the pursuit of happiness. But not all forms of happiness are equally acceptable. You can't claim taking drugs or smashing up bus stops as a human right just because doing so makes you happy. In fact, when people talk about a right to the pursuit of happiness, they mean something more elaborate, something more to do with human self-fulfillment. The point is, even a very ordinary word, like happiness, which you probably think you know pretty well already, has enough ambiguity in it to cause problems. The key thing for a critical thinker is to think about the context that words are used in. Who is using the word? Who is being talked to? What is the social and scientific context? The view you take of analogy can radically change how you read texts. There's a huge debate to be had about the extent to which ancient philosophy is literal. Did the ancient Greek philosopher Thales really think that the earth floated like a beach ball in a universe of water? Or was he perhaps onto something more subtle, that the earth is part of an invisible sea of energy? Or was he using water allegorically to mean that which flows and changes? People usually take Thales's words pretty literally and then chuckle over how simple his ideas were. You can read more about this in the nearby sidebar, Philosophers Arguing About Analogies. Tip: certainly the history of mathematics and physics consists of a series of ever grander analogies, and remembering this can help you make sense of it. Isaac Newton wrote of what he called the analogy of nature, giving as one illustration possible links between the musical scale and the colors of the spectrum. The great French mathematician Henri Poincaré was a keen thought experimenter and once wrote, "It is by logic that we prove, but by intuition that we discover." He often used analogies to help him along the route towards mathematical discovery. Philosophers Arguing About Analogies. Plato used many analogies, but warned his readers that likeness is a most slippery tribe. On the other hand, another great thinker, Immanuel Kant, wrote emphatically in favor of the technique, describing analogy as the source of creativity. In the 19th century, Friedrich Nietzsche did a bit of icon breaking by describing truth as a mobile army of metaphors. Icons are things, maybe statues or little pictures, that represent something else, and someone who breaks them is being iconoclastic. Nowadays, the Internet has breathed new life into the word icon, with everyone constantly associated with their own one. Continental, meaning mainland European, philosophers have historically been more enthusiastic about analogies and metaphors. This fits because in the world of philosophy, continentals are all about being mysterious and subtle. By contrast, historically, many English and American philosophers have seen their job as to eliminate linguistic ambiguities and to do away with imprecise, fuzzy thinking. But within science and mathematics, Einstein indisputably wears the hat of the great metaphorical thinker. For more details and how Einstein's famous formula of E equals mc squared came to him when he spotted a crucial similarity between two otherwise very different things, check out the nearby sidebar, Einstein's Route to Insights. One of Einstein's early analogies was of himself as a boy running down a pier with light as a series of waves rolling in from the sea. In this case, the analogy obviously reinforced his view of light as, well, waves, a view that he would free himself from only with difficulty later. Similarly, Einstein, like everyone, struggled against the common-sense view of light, which his theory treated as weighing something. Yet, how can light weigh something? It's hard to get much lighter than light. Warning. As you can see, word associations in general and analogies in particular can mislead as easily as they can help provide new insights. Fortunately, Einstein had such a love of conceptual similarities and hidden analogies that making one dodgy comparison never stopped his creative process. Einstein's Route to Insights. Einstein wrote a book describing how his thought experiments helped lead him towards his view of light as being made up of particles rather than waves, and the insight that time and space aren't two separate things but one, space-time, all tangled up. His famous equation, E equals mc squared, that is, energy equals mass times the velocity of light squared, is itself analogous to a vital, if rather mundane relationship in mechanics that says that kinetic energy equals mass times velocity squared, albeit with the whole lot divided by 2. The thing with imaginary examples is not to let them take over and start dictating policy, but to remember that they are, well, just imaginary examples. Equally, words can confuse and mislead, as the unconventional American anthropologist cum insurance man Benjamin Lee Whorf pointed out as part of his investigations into the workings of language. One example Whorf gives is of workers in a factory smoking near a drum full of highly flammable petroleum vapors. The workers are ignoring a notice that says, "Danger, empty petroleum drums." But because everyone associates something being empty with the absence of anything, the warning is ineffective, a bit like a notice that says, "Beware of nothing." The message really needed was, "Danger, petroleum drums full of flammable vapors." Confused comparisons and muddled metaphors. When you start to look, you soon find that lots of people make their points using analogies rather than arguments. Truly, an analogy is worth 1,000 words. In critical thinking terms, an analogy is valid when it identifies a similarity between two different things that sheds light on a particular issue. For example, someone might say that the premises of an argument are like the foundations of a building. If they are weak or flawed, then the argument will collapse. But what about analogies that don't really work? In this section, I discuss false analogies, which are comparisons that mislead rather than shed light. This may be because the items being compared do not actually have the factual properties attributed to them by the comparison. The comparison actually obscures differences that are more relevant or important than the similarity. The two items just are not similar enough to make the comparison work. There are plausible comparisons and links between two things, but the comparison made simply isn't one of them. The comparison, although not necessarily wrong, excludes important other possibilities. An example of a good analogy might be that one about the trapping of the sun's heat in the Earth's atmosphere by invisible gases. This physical effect is often compared to the trapping of heat in a greenhouse by the sheets of glass. This analogy is so common that it has become a noun, the greenhouse effect. It's useful because the gases do have a similar effect to sheets of glass. However, what about a comparison between running a country and running a corner shop? Such comparisons are usually made to demonstrate that governments must make their activities profitable and not behave like charities, or else they will go bust. This is surely a misleading comparison, as, for example, the aims of governments are to help people, whereas the aim of a corner shop is to make money. Secondly, when a government helps its citizens, for example through spending on education and health, it both saves money later and likely creates money by deepening the pool of skills available for industries and other businesses to draw on. Seeing false analogies in action. You encounter false analogies repeatedly in everyday life. For example, advertisers often compare their products to quite different things in the hope of persuading potential customers that in some crucial respect, a similarity exists between the two items. Driving a car is like flying a fighter jet. Eating some chocolate is like lying on a white, sandy beach in paradise. The only link offered is the feeling the consumer is supposed to get in the various cases. However, since hardly anyone really gets those feelings, the comparison seems a bit bogus. Another issue that brings up some dodgy, if not downright false analogies, is whether some kind of plan applies to the universe, or whether the world and everyone on it just emerged by chance. The chances of life on Earth emerging naturally has been compared to the chance of a functioning jumbo jet resulting from a bolt of lightning hitting a junkyard, an analogy that makes it seem very unlikely indeed. Nowadays, through the mechanism of natural selection, the principles of which ensure certain combinations succeed and spread and others disappear, scientists think that they can show almost all the steps to explain how the incredibly complex universe could have emerged from, if not nothing, certainly something very simple. They point out that the theory of natural selection includes a guiding principle, if not a guiding consciousness, which offers a way for complexity to emerge from chaos that's anything but random. For example, if rabbits used to have weedy back legs and run quite slowly, a random adaptation that resulted in more powerful legs and helped some rabbits run faster would seem likely to spread through the rabbit population, because the speedy rabbits would have lots of baby bunnies, while the slow ones would become dinner for foxes. The guiding principle is survival of the fastest. Whatever the truth of the matter, one thing is clear. The debate about whether or not an all-knowing being is needed to create the universe has produced more than its fair share of ingenious comparisons. Creationists, who think that God created the universe according to a plan, like to point out that the world is made up of many tiny parts that work together with the delicacy and precision of a fine watch. Now, a watch, in a sense, is just bits of metal and glass. But to understand what it really is, to appreciate the function of this or that little cog wheel or tiny spring, it does seem true that people need to recognize that it has been designed by a watchmaker to tell the time. So the claim made by the analogy is that to understand the world around us, we need to see each little bit not as merely metal and glass, but as having been designed to serve a certain purpose. Some people then move immediately to suppose that this designer is God. However, there are other ways to end up with a complicated mechanism like the Earth without having to have an incredibly skilled inventor and designer. In fact, biology and geography teachers often use the language of design, or things having particular roles and serving particular purposes, to do this when they explain, say, bees as being there to pollinate flowers, or earthquakes as the Earth's way of relieving pressure due to the movement of its tectonic plates. So I would say the watchmaker analogy for explaining the world around us is flawed, but not exactly invalid. Flawed because although not necessarily wrong, it excludes important other possibilities. Uncovering false analogies. Remember, people often use analogies for rhetorical effect rather than anything more substantial. In other words, analogies are often used to persuade people of a certain point without producing any supporting argument or reasons. For example, complex issues in bioethics are often distorted by the use of false analogies, with research involving, say, altering the genetic code of human embryos being ferociously condemned as creating Frankenstein monsters. Recall that the original monster was the product of Dr. Frankenstein sewing together various bits of dead criminals and bringing it all to life with a massive bolt of electricity from lightning. So the relevant similarity claimed is really the use of science and technology to bring life to organisms that would otherwise not exist with unknown consequences. That's true up to a point, but Frankenstein brings with it all sorts of negative associations. Tip: analogies are fine things, but be careful if your opponent knows how to ridicule them. Identifying the link in an analogy can often be the key to seeing if an argument is good or a stinker. Take this one as an example. Governments should behave like parents in a family. Parents need to have the ultimate say because they are wiser and their children do not know what is best for themselves. The idea that the relationship between citizens and governments is like that of children and parents is worth pulling out of many debates and looking at more closely. The supposed link is that parents have authority over children in order to protect them from harm, and that similarly, the state needs to have certain powers over its citizens for similar reasons. Yet, the comparison is misleading in many ways. First of all, government officials may not be wiser than the citizens, whereas parents are, by virtue of their age and maturity, in possession of far more relevant knowledge than at least young children. Teenagers inevitably end up discovering just where parental wisdom runs a bit short. Another way in which the comparison falls short is that parents usually have to do, certainly to live with, whatever is decided, whereas governments can carry on very well even after forcing disastrous policies on their citizens. No one made Stalin try out his new farming techniques. Finally, most parents, whatever the wisdom of their views, do love and care for their children, but lawmakers and government officials, alas, don't always have the interests of the common people at heart. Becoming a thought experimenter. Right, enough theory. Now let's try some practice. The grand claim made for thought experiments is that they are a powerful way to gain knowledge about the world, by means of pure thought, by armchair philosophy only. Indisputably, whether or not they are called thought experiments, the approach has had an important role not only in theoretical philosophy and not only in practical science, but in all areas of thought over the centuries. In this section, you get the chance to observe some famous thought experiments in action. The term thought experiments has no precise agreed meaning, but it covers a range of techniques from imaginary what-if scenarios to fables and allegories and carefully worked out hypothetical examples, or even models. Discovering thought experiments. Although the term is slightly vague and people use it in different ways, the first thought experimenters were definitely philosophers. Seeing how they used the method can reveal something about how critical thinkers can use it too. Here's the kind of thought experiment that everyone can relate to. Schrödinger's cat, named after the physicist who invented it. The issue is from science and concerns the theory, which is the current consensus, that in the subatomic world the existence of particles is affected by whether or not they are observed. Professor Schrödinger thought this was absurd, so he came up with this what-if challenge. Imagine there is a cat locked in a box with a radioactive atom and a Geiger counter. If the atom decays, then a particle is released, but no one would know. Now, fiendish touch, suppose that the Geiger counter is set up so that if it registers a particle, poison gas is released and the cat dies. If the atom doesn't decay, no particle, no triggering the Geiger counter, and the cat stays alive. The point of the experiment is to illustrate the strange consequences of the theory that in the quantum, meaning very, very small world, subatomic particles both exist and do not exist at the same time. Professor Schrödinger's imaginary experiment seems to put the cat in the same position of existing and not existing, which is ridiculous. And that is his point. He thinks it is ridiculous to suppose that subatomic particles can both exist and not exist at the same time, and are affected by whether anyone is watching them. His experiment links our furry friend's existence to the particle's state, with a mechanism that is practically possible, if rather unlikely. He challenges anyone who says, "Why, yes, subatomic particles can both exist and not exist, no problem," to also say the same thing about cats. Does the thought experiment work or mislead? See the Answers section at the end of this chapter for one objection. The great advantage of a thought experiment over, say, practical research is ease. Anyone can come up with a thought experiment, and the evidence it provides is free. Take a question like one that might come up in sociology, whether people are fundamentally good but are pushed towards bad behavior by circumstances. Well, one way to investigate it might be to look at lots of prison records and see the backgrounds and experiences of criminals. But another way would be to imagine some extreme examples, and then, simply by using informed guesses or intuition, imagine what would happen next. Plato's imaginary story of a shepherd who finds a magic ring seems as good a way to investigate human nature as cataloging any number of real-life cases would be, and it's certainly a lot easier to do. Plato suggests the shepherd, because of being untouchable, will stop being a good, hard-working citizen and instead become a cheat and rogue. On the other hand, magic rings, like many thought experiments, are basically impossible. Can reliable conclusions be drawn from arguments that start with impossible assumptions? Strictly speaking, they cannot, as the rule for sound arguments is that the premises must be true. If the premise is impossible, it can't be true. I'm not going to try to solve that problem, though, for the technique here. Suffice to say that plenty of very practical issues in economics, in physics, in mathematics have been explored with thought experiments that include within them completely impossible assumptions. In a way, that seems to be another powerful feature of the technique. At its simplest, a thought experiment is a simple imaginary example, a what-if. You probably use this kind of example yourself all the time, without noticing. Certainly teachers use it in schools, usually to tell children off. What do you think would happen if everyone walked on the flower beds? What if I decided I didn't want to come to school but to carry on playing football with my friends? Meaning that there'd be no lessons, and that would be awful, of course. Another powerful but simple thought experiment technique simply involves substituting one element in an argument for another. For example, suppose someone says that it must be wrong to eat dogs because they are often kept as pets. In that case, you can test their claim by swapping the animal in question for another, perhaps horses. Horses are often kept as pets, but are still eaten in much of Europe, and even as delicacies in certain posh restaurants. Now, this argument doesn't prove eating horses is right, but it does highlight a weakness with the supposed rule. Dropping Galileo's famous balls. Critical thinking in action. As well as being one of the most famous thought experiments of them all, Galileo's balls is also one of the simplest. This experiment is the classic example of a skill that all critical thinkers must have. The matter being investigated was whether heavier objects fall faster than lighter objects, the kind of question that you might well suppose called for some practical, not thought, experiments. But the Italian philosopher, mathematician, and astronomer Galileo proved that just by thinking things through, we have all the information we need already, without needing to start dropping lead weights or the like. The thought experiment demonstrates the power of the technique for much more important things than mere physics. If you can make sense of why this one works, then you can really get a eureka moment and insight into the whole notion of reasoning by analogy. The example of Galileo's famous balls also illustrates several crucial features of thought experiments. One is that they all follow the critical thinking pattern of presenting a series of assumptions. Another is that there is no attempt to root the starting assumptions in reality. They are just imaginary starting points. You might say, but why not start with facts? The point is that the focus in a thought experiment is on the argument and reasoning, not on the premises. Galileo's thought experiment really does prove something, one of the most important ideas in physics. The experiment, but it's imaginary, remember, starts with Galileo climbing the Leaning Tower of Pisa, leaning over the parapet and dropping two metal balls, a large heavy one and a smaller lighter one, and watching to see which hits the ground first. Galileo was thinking of one of Aristotle's laws, which said that the rate at which an object would move depends on how heavy it is, and rather tidily, too. If one weight falls a certain distance in a certain time, then Aristotle said that a half as heavy weight would take twice as long to fall. But Galileo didn't want to think of feathers and hammers. Instead, he was thinking balls. No sniggering at the back. Which ball do you suppose would reach the ground first? According to Aristotle, the large ball would hurtle to the ground twice as fast as the light one. Well, maybe. But now here comes the power of the thought experiment technique. Imagine that you tie a piece of string between the two balls. Then, what do you suppose would happen? Here's where the critical thinking process starts. First of all, assume that heavy objects do fall faster than light ones. In that case, the heavier weight falls, as in Figure 5-1, with the lighter weight acting a bit like a parachute, as it were. Thus, the two balls together fall more slowly than the heavy weight would on its own. On the other hand, when the two weights are tied together and held out over the parapet with the string pulled tight, they've effectively combined their weights, becoming one greater weight. Imagine holding the little weight with the big one dangling beneath it. Now, as the little weight falls, it's surely going to be pulled down even faster by its big companion. So, seemingly, putting a cord between the two weights together must make them fall more slowly, and yet equally must make them fall faster than when they were released separately. Now, philosophers love a contradiction, which in this case can only be avoided in one way: to assume that the heavy and light weights fall at the same speed. Does the experiment work? Yes. Physicists know the principle that it established, that all bodies fall with the same acceleration irrespective of their mass and composition, as the principle of equivalence. It led directly to Einstein's general theory of relativity, which explains gravity by saying that when the Earth orbits the Sun, it's falling through curved space-time. How about that for the power of thinking? Splitting brains in half with philosophy. Many thought experiments force you to rethink, critically, assumptions that you had originally taken for granted. This happens even though the experiments themselves may be a little ridiculous. Remember, that is because it is not the facts that are deciding the case, but the reasons used to draw conclusions from them. A great way to see how thought experiments can test assumptions is to consider a gory one involving cutting up brains. In fact, tinkering with the human body has often appealed to thought experimenters. Typical is an experiment proposed by the 20th century American philosopher Derek Parfit. Imagine, he says, that a surgeon carefully removes someone's brain and then reinserts it into someone else's body in such a way that the original person's memories and personal psychological characteristics were intact enough for people to feel it really was them afterward, only in a new body. Okay? Now imagine, a fiendish touch, that half a brain turns out to be enough to do this. Surely not an impossible supposition. Yet in that case, potentially you can make two new people, say two new Derek Parfits, out of one. Therefore, saying which person is the real Professor Parfit would be impossible. As with the Galileo example in the preceding section, the result is a contradiction. The idea that one person can become two, or maybe three or four, as neuroscience and surgical techniques improve, is unacceptable to other firmly held beliefs. The experiment thus forces people to rethink, critically, their assumptions. Answers to Chapter 5's exercises. Here are the answers to this chapter's earlier box-em-up exercise. How did you get on? The categories are fairly uncontroversial. Jupiter, Saturn, Mars, Pluto, and Venus are all planets. 3 o'clock, tomorrow, the Stone Age, Wednesday, and 1964 all have to do with time. Mumps, tonsillitis, Asperger's syndrome, acute nasopharyngitis, and a fractured hip are all illnesses. Acute nasopharyngitis is actually the common cold. Minim, deed, tenet, God's dog, and too hot to hoot are all palindromes, words or phrases that read the same backward as they do forward. But deciding on the odd word out is much more subjective than tests often allow, and many answers are possible. In fact, you can often identify more than one category for some lists, too. Pluto was recently reclassified as a dwarf planet on account of it being little more than a large rock with an irregular orbit around the Sun. Tomorrow is the only measure of time that's relative. Tomorrow will be a different day in a week. Asperger's syndrome isn't really an illness. Did I say it was? You should have challenged me. It's considered a psychological disorder characterized by difficulties in social interaction and communication. But an equally valid distinction would be that the fractured hip is the only trauma, injury. God's dog is the only palindrome with an apostrophe. Admittedly, that seems pretty arbitrary, but it's still a fact. Schrödinger's cat. One objection would be that cats are conscious too. Maybe they cannot talk, but they can surely tell if they are being poisoned, so that means that if inside the box the chain of events was started with the release of the particle by the atom, the cat would not be in a suspended state of being both alive and not alive anyway, the implausible state that the experiment is supposed to mock. Chapter 6. Thinking in Circles, the Power of Recursion. In this chapter, refining your thinking to make it more powerful, dialing into dialectical thinking, taking practical ideas from design philosophies, spotting the important points in an argument. Carl Hempel, a 20th century American physicist, once noted one of the great circles of science, that theories don't appear in a puff of smoke, but emerge out of a chain of events, starting with guesses about patterns that may or may not be there in the data. The guess then influences the selection of data, and that, in turn, affects the exact nature of the scientific theory. Science is actually a kind of a chicken and the egg situation. Which comes first, the theory or the observation? And like the chicken and the egg, really it doesn't make much sense to try to answer that. One affects and requires the other in a perpetual circle. At school, however, students are encouraged to think in straight lines, to start at the beginning, work their way through the middle, and then stop at the end. But in the big wide world, things are more complicated than that. Nature is all about cycles and circles. Hardly surprising, then, that critical thinking encompasses all shapes and sizes of thinking, by which I mean not only the linear logic of informal arguments, with their sequence of steps from premises to conclusions, but also powerful techniques of thinking, with their roots in many different areas of life. In this chapter, I start by looking at some of the powerful techniques that lie behind computer science, and also at some of the great ideas from design philosophies used across a broad swath of practical subjects. Both approaches emphasize the idea of repeating processes to refine an argument in order to progress. And in between, I take a look at a powerful circular idea from philosophy: dialectical thinking. One of the great tips from design thinking is to generally avoid yes/no language and interact with other people in a nonlinear, less directive way. Instead of questions and answers, which are like a series of straight lines, sometimes it is better to go for stories, which are like shapes. And so to finish this chapter, you can test your skills on a real story, which contains within it a real argument as a practical exercise. Then you may want to return to the start and read this introduction again. Thinking like a computer programmer. If you find the potential implication behind this heading scary, let me reassure you. When I advise thinking like a computer programmer, I don't mean the following type of yikes-inducing thing. X equals 3, go to line 24. Stop, exclamation point. Next Y. Repeat until, quote, bedtime is true. Hello world, exclamation point. No, the things to admire about computer programming are much less to do with mathematics and much more to do with communication, language, and arguments. First of all, software designers have to work out exactly what the problem is before they can work out how to program a computer to do it. There's no chance that a computer will guess what a programmer meant to say, so programmers have to be very clear in their own minds and able to communicate their message without ambiguity. This skill is just as important for critical thinkers. A second powerful technique for critical thinkers that is used every day in computer science is recursion. What's that then? Going around in circles. Far from being a sequence of different instructions, computer programs endlessly refer back to themselves. One section or procedure calling up another section, which in turn calls up another, which perhaps checks back with the first, only this time with new information to process. The key idea to grasp here is that a circle in computer programming means a series of steps repeated, and repeating things is not bad. This ability to tirelessly repeat steps isn't a weakness or an admission of defeat, but a central strength of programs. Another principle of computer science worth borrowing is that of modularity. Instead of having one great long text with everything in it, you have a series of short, discrete sections. Books like this one have taken a leaf out of computer science, because the material is arranged so that it does not have to be read in one long linear sequence, and you can dip in and out of it to create your own sequence of reading to suit your precise needs. Taking tips on clarity from programmers. The first thing computer programmers have to discover is how to express themselves clearly. The machine doesn't guess what you mean. Computers just follow instructions, with one step following another. In fact, the most dangerous step a computer can take is the one that starts a circular sequence of instructions that will never end. When your computer stops working in the middle of an operation, it is usually because the program is doing this. It is not for nothing that the jokers of Apple named their posh California HQ #1 Infinite Loop. Now, you may think that expressing yourself clearly sounds like something you're already pretty good at, but try explaining how to tie a shoelace to a 5-year-old without demonstrating the method physically. Take a lace, pull it tight. Take the other lace, pull it tight. Pull the first lace so that it's under the second lace, and then twist it so that it makes a kind of circle. Oh dear. Place it under the other lace and... In fact, explaining how to tie shoelaces has always been considered a tricky problem, and computers are usually given simpler tasks. But whatever the job, long before the programmer gets down to the basics of coding the if x equals 2, then y minus y plus 1 sort of stuff, someone has analyzed the task and come up with an algorithm to solve it. Thinking methodically with algorithms. Algorithms sounds like a type of jazz funk music, algorithms, but the word really means a sequence of steps taken to solve a problem, a methodical strategy for solving problems in a systematic manner. This type of approach is integral to critical thinking, particularly critical writing. Here, the sequence of steps in an essay or book is crucial. The more complex the arguments, the more you need to have a clear plan, and what is more, to communicate the strategy to the reader. Readers need to know how the parts of the argument connect to each other, to be given signposts and summaries. Stripped down to their essence, these kinds of structural considerations constitute an algorithm. Approaching the chaos. At first sight, problems can look chaotic. They need to be analyzed and broken down. But how do programmers, or indeed anyone, move from chaos to order? The bottom line is that no explicit way exists of devising an algorithm for a new problem. Instead, this part remains rooted in creative insight. In other words, to be good at solving problems, you need to be able to think divergently, to think about lots of possible solutions. Sometimes, faced with an issue, this kind of thinking is done without you even being aware of it. And when the answer occurs to you, it seems to pop up out of nowhere. Here's a real-world problem to solve: the maze flowchart, which shows you how to express a problem in a precise and unambiguous form. In so doing, you may find that your understanding of what is required is not quite as clear as you thought. A group of tourists have to find their way through a maze of streets from the town gate to the cafe. Check out Figure 6-1, which can be found in the print and e-book versions of this book. Think about how a computer programmer may set about writing an algorithm to help tackle this issue. Looking at the figure, I expect you can see that one answer could consist of a series of very precise instructions, the sort you'd get from a knowledgeable local. 1. Enter the old town through the town gate. 2. Turn right. 3. Take the first left. 4. Turn left at the end of that street. 5. Turn right at the end of that street. 6. Turn left at the end of that street. 7. Turn right at the end of that street. 8. Keep the houses always on your left and just keep walking. The cafe will be there. Now that's the kind of algorithm that I can come up with. It has a few weaknesses, however, notably that it applies only to one very particular problem, one particular walk from one particular starting point through one particular maze of streets. And what if no one knows the town well enough to give this sort of turn-by-turn guidance? Can you produce an alternative set of instructions that not only gets the tourists safely to their lattes and cappuccinos, but also works in lots of similar town-like mazes? Flip to the later section, Answers to Chapter 6's Exercises, for an answer. Notice I say an answer, not the answer. Producing a solution. If you think like a computer programmer, you have no trouble coming up with an alternative plan for the maze problem. To begin with, you make sure that you know the starting conditions, which in this case means that you insist on always entering the town through the gate, as shown on the map. That's the same as before, but then the rules are different. They're systematic, in the sense that they provide a system for dealing with all possible similar situations. Rule 1. Always walk forwards unless a row of houses blocks you. You face a choice of paths, or, of course, you find the cafe. Rule 2. Whenever you encounter a choice of paths, choose the right-hand turn. Rule 3. Whenever the path is blocked, turn around and walk back to the last place with an unexpected choice of path and take the left-hand one instead. This solution isn't brilliant because in most cases the tourists end up walking most of the town before they find the cafe, but it will get them there. And computers don't mind trying out lots of options because they can do so quickly. As before, the tourists just have to follow the instructions. They don't need to worry about never getting lost because the system is all they need. Tip. Notice that the maze program contains circles. That's easier to see if you represent the 3 steps in a diagram. Even if you're not used to thinking diagrammatically, have a go. Trying to put things into a diagram is great for concentrating the mind. Distinguishing between semantics and syntax. Tip. To express yourself clearly and effectively in writing or speech, try being more like a computer and less like Shakespeare. Construct your sentences so that the meaning is unambiguous, and listeners or readers can easily follow your line of reasoning, instead of leaving them to imagine alternative arguments you've never dreamt of. Remember, a useful distinction in computer programming in this regard is between semantics and syntax. In ordinary language, semantics. This covers questions about the meaning of words or phrases. Syntax. This concerns putting the words and phrases together correctly, grammatically, and considering their positions and relations to each other. Trainee programmers regularly get that awful message, syntax error. But computers never ever complain about semantics because they aren't interested in the meaning of words, or even of numbers. They're symbol processing machines that just move zeros and ones around very fast. In contrast, natural languages, such as English, are hugely complicated in terms of syntax. Take a phrase like turn off. It can have many meanings in English. You can turn off a light, turn off a road, or turn off studying. In this sense, the English language is very flexible, which makes it tricky. But in other ways, it is inflexible, which also makes using it hard. For example, unlike other languages, English has strict rules governing the structure of sentences. One is that you usually have to use a subject-verb-object pattern. For example, the students, subject, study, verb, the rules of thinking, object. If you write, for instance, study the rules of thinking, the students, or the rules of thinking, study the students, people will get confused. A computer program pretty much defines its own rules for how to handle the content. In other words, it defines for itself the syntax that controls which words the computer understands, which combinations of words are allowed, and the punctuation that must be used too. Critical thinking is about avoiding ambiguity and confusion, so leave poetic flourishes to others, or, okay, we love 'em, to the final sentence, and become a devotee instead of correct syntax. The rules of syntax for natural languages aren't completely defined, and many forms, words, claims, phrases, sentences, are ambiguous. Take even that most serious verb, to die. Most of the time, this verb's meaning is pretty well fixed, but you'd be silly to be too worried if you were told that your friend had died when selected to sing Madonna's Like a Virgin at the office Christmas party. The nearby sidebar Playing at Semantics has more on such complications. Almost every word has another sense, as stand-up comedians know very well. Normally, however, people hardly notice the ambiguity of language because they're so good at guessing the meaning from the context. Computers, even today, are lousy at this. Playing at Semantics. Here are some snippets of conversation that you might overhear in a bar. Uneducated folk, obviously. But, uneducated or not, there's one phrase you are extremely unlikely to hear. Can you spot it? I like drinking beer. I like men to drink beer. I like women to drink wine. I don't like drinking beer. I don't like men to drink beer. I dislike women to drink wine. Oops, syntax error. Although saying I like to do such and such is a very useful standby in English, you can't really say I dislike to do such and such. Nonetheless, if someone did say it, the meaning would still be quite clear. The expression is semantically okay, but syntactically incorrect. The other side of the coin is when sentences are semantically confusing, but syntactically perfectly correct. For example, the question, why can't journalists take pictures of people with wooden legs? The answer, because you need cameras to take pictures. Remember, if you can't explain your approach to a problem in a form that can later be turned into a computer program, you probably aren't being quite clear enough. Thinking dialectically. Dialectical thinking is a form of analytical reasoning that claims to refine knowledge and pin down truth through highlighting contradictions. Supporters of the method say it encourages the ability to view issues from multiple perspectives, as well as to reconcile seemingly contradictory information and positions. The approach is traced to the writings of the German philosopher Georg Hegel in the 19th century, but like most things in philosophy, it really goes back a lot further. Certainly, Socrates' method of posing contradictory questions, made famous by Plato's dialogues, is very similar. Socrates always presented his debates as essentially team efforts to uncover the truth. Not so Hegel, His idea was that debate is a process of conflict in which two views fight it out. I'm sure we all know lots of discussions that take this negative form. However, Hegel's interesting idea was that when an idea or theory is opposed with a contradictory one, what results is a third idea or theory that combines elements of both of them. Technical stuff. Actually, Hegel tended to split everything into two opposed extremes, not just theories, which he then predicted would always fight it out until a new third force emerged, combining the best of the previous ones. For example, he supposed that in the distant past human beings had split into the two groups of masters and slaves, and the necessary result was an all-powerful state. His theory was picked up by Karl Marx, who suggested that human history was dialectical too, with the key conflict being between workers and capitalists, a battle that would inevitably result in world socialism and classless society. He didn't seem to consider the possibility of capitalism winning, but then Marx was not a true critical thinker, more of an ideologue. Hegel was very proud of his idea, which he saw as entirely novel and very powerful. I'm not sure it is either, really, but he did touch upon something important for critical thinking, which is that it often does help to deconstruct issues by identifying two opposing views or perspectives and then trying to find a way to combine or reconcile them. This new view would need to combine elements of both and supersede them, and would then offer a more complete perspective on the issue than could have been obtained if you tried to avoid the conflict in the first place. Another characteristic of dialectical thinking is that the new view inevitably creates its own contradiction. As Hegel puts it, that is to say, every new idea produces an opposed critique, or at the very least, a refinement of the idea. Sure enough, these two views eventually have to battle it out too. Technical stuff. Hegel says that his new dialectical form of thinking is superior to the old ways, the structured thinking kind and the intuitive or emotional kind, because it includes already within it multiple perspectives and seemingly contradictory information and positions. He sums up this idea of continually bringing together opposites under new headings by saying that philosophy resembles a circle of circles. Sort, select, amplify, generate. Using design skills to see new solutions. You may be skeptical about the idea that design philosophies can offer you a powerful set of tools for thinking. But these design skills aren't about constructing items from wood or fabric in the workshop. Instead, they draw on ideas and experience from design and engineering, as well as social science, business, and computer studies. Remember, the philosophy of design is very old and predates engineering. One of its most characteristic parts, and the most useful for critical thinking, is that it puts the human factor at the heart of its solutions. For an example, see the nearby sidebar, Powers of 10. This section is all about how to treat data, or in a broader sense, how to refine ideas. The language sort, select, amplify, generate is that of computer science, but the concepts are universal. Critical thinkers need to organize their thoughts, weed out the irrelevant aspects, expand on the key issues, and hopefully emerge with something new and original at the end. Powers of 10. Here's a great idea from Design for Critical Thinkers. A strategy called Powers of 10, sometimes called a reframing technique. Basically, the method is to exaggerate everything and take it to the extreme. If, say, you're designing a play area for children on a budget of $1,000, you may ask, what if the budget is only $10? Or, what if it's $1 million? If the area is likely to fit in a classroom, you may ask, what if it's just 1 meter square? Or what if it's the size of the playing field? Just as a picture can look very different if you put it in a different frame, reframing issues and problems that you are tackling can bring about a surprisingly big shift in how you think and feel about them. In this section, I examine Check All the Angles, which is a simple way to reveal contradictions and conflicting views that may be blocking the finding of solutions. An important idea in software design is called State, Gather, Analyze, which is about how to handle information, and then it's back to circles again, or at least loops. The section Look Close, Look Away, Look Back, and the sidebar Why Ask Why will give you some practical tips that will help you both to generate insights and to help them grow. Check all the angles. Tip: checking all the angles is a standard tool from Design Skills that's elementary but efficient and incredibly simple to do. It's used for unpacking contradictions and highlighting possible conflicts, always a useful skill in critical thinking. Here's how it works. On a sheet of paper, write a question, or problem, or issue at the top. Below that, draw a square, then split the square into quadrants that indicate the following. First quadrant. This concerns the what and the how of the issue. Put your observations and experiences here. Second quadrant. This is to examine who and why. Who gains and who loses. Try to guess what is motivating everyone too. Third quadrant. This relates to values, whether it's good or why just maybe it's a bad one. Think about the overall aims and context here. Fourth quadrant. This looks at the practicalities, the when and the where, but how and who may come into it again too. Pause a moment and think about the third quadrant here. In the West, people normally assume that thoughts are an inner silent language in their brains. But there are plenty of other philosophical and cultural traditions that think about thinking as a much broader process, encompassing not only thoughts as a kind of inner dialogue, but also feelings and emotions, sensations and perceptions, and even a feeling of a sort of inner awareness. I'm talking meditation now. With that in mind, let's test the approach out with a question. How can I get a job as a radio presenter? In this case, the sort of things that you might put in the 4 quadrants might be: first quadrant. I want to be on a big national station, not just a little one. Definitely not hospital radio. Second quadrant. I suppose I want to feel important and be popular. Plus, it's a great way to hear music and meet cool people. Third quadrant. Maybe I need to get out more, make some new friends. Plus, I used to want to be a doctor and help cure people. As someone said to me just the other day, ultimately, in life, meaning comes from the people you touch. Fourth quadrant. I should try finding out a bit about how all the famous DJs got their jobs, and maybe go to my local radio station and ask if they offer any work experience. I have to get some experience first on, maybe, hospital radio. Don't get hung up on which point goes where. There is a lot of overlap in the potential interpretations of the quadrants. The point is really to trigger ideas and encourage people to step back slightly from an issue in the hope that this brings a new perspective. It can be a great way to get a new take on a student assignment, for example. The idea is that insights emerge from contradictions, like the hospital radio one, within a quadrant or from two different quadrants. The unpacking method is similar to the idea of having a critical reading checklist. David Larrabee of the Stanford School of Education developed the original checklist tool, and noting what he had in mind is useful. He says that people should always ask themselves questions in 4 basic areas about their point of view, which I summarize as follows. What's your aim? What's your perspective or framework? Is it user-centered, needs-based, or insight-driven? Who says? How valid is your point of view? Is your position supported by evidence and experience? What's new? What's significant? Why does your point of view matter anyway? Who cares? How will it make a difference? Remember, these questions correspond to the 4 quadrants. But the important thing isn't to put points in the correct corners. It's to think through issues from all the angles. State the problem, gather relevant information, and analyze the implications. Remember, solving a problem involves several stages, but the most difficult part is knowing how to pose it. In fact, before you can state the problem effectively, you need to clarify its nature and have some idea about the sort of answer you're looking for. Only when you have a working notion of these aspects can you formulate questions and start to gather information systematically. So formulating questions is not only the necessary first step, but part of the second and third steps. Once again, the critical thinker needs to be prepared to think in circles by being prepared to go back to stage 1 after refining ideas as part of stages 2 and 3. As you gather info for these purposes, you need to collate and organize it, in the process condensing and summarizing the information. Analyzing the material should enable you to make better sense of the original problem, so you may want to go back to where you started and fine-tune the questions you started with. There's a long tradition of that, too. The philosopher credited with bringing in scientific thinking, René Descartes, advised his readers, in what is in many ways a foundation text in critical thinking, the Discourse on the Method, published way back in 1637, something similar, to divide each of the difficulties under examination into as many parts as possible and as might be necessary for its adequate solution. You may also want to break the problem down into smaller, more manageable parts, each with its own information-gathering procedures. Practice your skills by investigating this rather tricky example, which I call Help Me. Stating the problem is easy, but do you also need to gather and/or analyze? Joanna's mother has had 3 children, all girls. The first child she named April. The second child she named May. Got all that? Now, what do you think was the third child's name? The closing section, Answers to Chapter 6's exercises, has the answer. Look close, look away, look back. Where others look for clarity and precision before starting, design skills encourages ambiguity and vagueness. It suggests that you start with a vague impression of the whole and then take a series of ever closer looks at the issue. These are called look close, look away, look back loops, and ideas emerge and take shape during these stages. Loop 1. Ask why. Designers use lots of brainstorming techniques that often boil down to the simple skill of asking yourself questions. Even when you think you know the answer, ask people why they do or say things. The answers may surprise you. Tip: obviously, don't annoy everyone by simply repeating why, like a mantra, but pick up elements of what others have said and then press for new information and insights. The nearby sidebar, Why Ask Why, contains a couple of examples. Loop 2. Test your idea. In a design context, the testing may be by making a physical prototype or just by imagining something. The key thing is to suppose an action, think about what effects and consequences may follow, and then take those insights back to your starting idea to see whether you can improve it. This process is often called iteration. The key idea is that the more times you go around the cycle, the better. Try to avoid facts. Tip: another way to get new and broader insights when talking about issues and problems with other people is to avoid factual exchanges. Why ask why? As a general rule, asking why leads to ever more general, abstract replies. These abstract statements are often more meaningful when not as directly applicable to the first answers. Take, for example, these short interrogations. Me: cats should have to wear bells around their necks. You, Loop 1, just ask why. Why? Me: to stop them killing little songbirds. You, Loop 2, testing. Why is that important? Me: because we need biodiversity. Or this one. Taxi driver: the police should not be allowed to just stop law-abiding people at random. You, Loop 1, just ask why. Why? Taxi driver: because it wastes valuable time and is annoying. You, Loop 2, testing. But why do you find it annoying? Don't you like helping the police? Taxi driver: but it's not like you're helping them. They give you the impression that you're kind of a criminal. As a practical tool or a group activity, why questions and responses can be visualized as a rising ladder. The first statement is the bottom rung, and the aim is to ascend to get the general overview, sometimes called why-how laddering. For example, if you're talking about gardening or landscaping, don't ask, when is the best time of year to plant trees, but rather, tell me about your successes and failures in planting trees. The first kind of question gets a pretty short answer, in the autumn, whereas the second kind may produce unexpected extra information. Design thinking encourages storytelling. This goes against many prejudices you may have from school. Stories aren't reliable, aren't true. But whether the stories are true is irrelevant. They reveal how people think about the world. Storytelling is a deeper form of communication than the mere exchange of facts. And when people draw on more profound insights, you're likely to spot more inconsistencies. But don't criticize and tell them to think harder. In design thinking, inconsistencies are much valued paths to interesting insights. Remember, observing the difference between what people say and what they do is worth any number of facts in terms of understanding processes. Inconsistencies are precious clues giving access to the most profound insights. Ordering yourself a nice, fresh argument. Exercise. In this section, I've come up with the kind of exercise that students regularly use in critical thinking courses. To explain, they are given an extract from a published source. Often it is less fun than this one, but the principle is the same, and asked to identify elements of the argument. A sizable proportion not only of conventional critical thinking courses, but generalized intelligence testing is devoted to this kind of stripping down of texts for the core structure and argument. I have used the story of Frankenstein to give you a more light-hearted opportunity to practice a very business-like skill. The extract is from Mary Shelley's classic novel, Frankenstein, which is the name of the mad professor, by the way, not the large and ugly creature he creates out of bits and pieces of bodies robbed from the local churchyard. Anyway, near the beginning of the story, before he goes rampaging around, the monster tries to insist on his right to have a companion in life. Your task is to help Dr. Frankenstein's monster by putting his assumptions up front, along with evidence to support them, all in short bullet points. Also, aim to pin down the argument that will persuade anyone who accepts the monster's premises to also accept his conclusion. So, jot your ideas down and then see the next section for my take on the answer. The being finished speaking, and fixed his looks upon me in expectation of a reply. But I was bewildered, perplexed, and unable to arrange my ideas sufficiently to understand the full extent of his proposition. He continued, "You must create a female for me, with whom I can live in the interchange of those sympathies necessary for my being. This you alone can do, and I demand it of you as a right which you must not refuse to concede." The latter part of his tale had kindled anew in me the anger that had died away while he narrated his peaceful life among the cottagers, and as he said this, I could no longer suppress the rage that burned within me. "I do refuse it," I replied, "and no torture shall ever extort a consent from me. You may render me the most miserable of men, but you shall never make me base in my own eyes. Shall I create another like yourself, whose joint wickedness might desolate the world? Begone! I have answered you. You may torture me, but I will never consent." "You are in the wrong," replied the fiend, "and instead of threatening, I am content to reason with you. I am malicious because I am miserable. Am I not shunned and hated by all mankind? You, my Creator, would tear me to pieces and triumph. Remember that, and tell me why I should pity man more than he pities me. You would not call it murder if you could precipitate me into one of those ice rifts and destroy my frame, the work of your own hands. Shall I respect man when he condemns me? Let him live with me in the interchange of kindness, and instead of injury, I would bestow every benefit upon him with tears of gratitude at his acceptance. But that cannot be. The human senses are insurmountable barriers to our union. Yet mine shall not be the submission of abject slavery. I will revenge my injuries. If I cannot inspire love, I will cause fear, and chiefly towards you, my archenemy, because my Creator, do I swear inextinguishable hatred. Have a care. I will work at your destruction, nor finish until I desolate your heart, so that you shall curse the hour of your birth." A fiendish rage animated him as he said this. His face was wrinkled into contortions too horrible for human eyes to behold. But presently he calmed himself and proceeded. "I intended to reason. This passion is detrimental to me, for you do not reflect that you are the cause of its excess. If any being felt emotions of benevolence towards me, should return them 100 and 100-fold. For that one creature's sake, I would make peace with the whole kind. But I now indulge in dreams of bliss that cannot be realized. What I ask of you is reasonable and moderate. I demand a creature of another sex, but as hideous as myself. The gratification is small, but it is all that I can receive, and it shall content me. It is true, we shall be monsters, cut off from all the world, but on that account we shall be more attached to one another. Our lives will not be happy, but they will be harmless and free from the misery I now feel. Oh, my Creator, make me happy. Let me feel gratitude towards you for one benefit. Let me see that I excite the sympathy of some existing thing. Do not deny me my request. I was moved. I shuddered when I thought of the possible consequences of my consent, but I felt that there was some justice in his argument. Mary Shelley, Frankenstein, 1818. Answers to Chapter 6's exercises. Here are the answers to this chapter's earlier exercises. The maze flowchart. Take a look at Figure 6-2, which can be found in the print and e-book versions of this book, for one approach to addressing this problem. Help me. The skill needed is definitely information gathering. No deep analytical skills at all are needed. The girl is called Joanna. Be careful that your assumptions, perhaps about the progression of months, don't blind you to solutions. The monster's argument. As with many real arguments, the monster's conclusion is put first, before the evidence and before the argument. You must create a female for me. He claims it as a right, and a crucial part to note is his claim for a right to companionship. Everyone has a right to companionship, premise 1. The only possible companion he can have is another monster, premise 2. Therefore, Dr. Frankenstein must make him a companion. Conclusion. Also, as in many real arguments, the monster includes some supporting evidence, expressed as statements of fact. These claims aren't really necessary for his main argument, but rather seem to be pressing his case to be considered on the same basis as everyone else. The monster's bad behavior is only because he's miserable otherwise. He'd be a creature of good character and return kindness shown to him 100-fold. He's miserable because he's lonely and shunned by everyone. He says, if I cannot inspire love, I will cause fear. Chapter 7. Drawing on Graphics for Thinking. In this chapter, mapping ideas with charts. Seeing graphical tools in action. Discovering powerful tools for thinking. It's lucky that there are more ways to try to understand things than by using reason alone. The human mind is actually very good at grasping complex relationships expressed in pictures and diagrams, for example. But how do you get an issue usually addressed in words and sentences to become one expressed graphically? This chapter is about how to do exactly that, and to draw upon maybe unsuspected powers lurking within you. Take mind maps and other kinds of concept charts to start with. These extract ideas from your head and turn them into something visible and structured. Sounds good, right? Well, they are, but here's the catch. Although you can dash off the simplest charts fairly effortlessly, the more useful ones require a lot of thinking. Not only that, but they require a lot of different kinds of thinking. Hence, the huge difference between a good chart, a useful chart, and a bad one that sheds no light at all. We all know this from dashed-off newspaper or TV news graphics. In this chapter, you not only find out how to use graphical elements in a critical thinking context, which everyone seems to be doing nowadays, but also how to do so meaningfully, which is rather rarer. Think of this chapter as the art one of the book, your chance to use different color pens, browse clip art, and maybe try out some computer design packages. Remember, the pictures, or more accurately, the diagrams you end up with, aren't just pretty illustrations. They're ways of coming to deeper insights and more sophisticated understandings of issues and processes. And that's why, in this chapter, I also look at some other tools that can do this, including several different ways of brainstorming, the art of summarizing, and a variety of approaches to the technique known as triangulation. Sounds complicated? They're not, and I explain why. Discovering graphical tools, mind mapping, and making concept charts. In this section, I introduce some graphical tools that critical thinkers can use to gain insights into complex conceptual relationships and clarify issues. I call them all concept charts, but you can find plenty of other names being used, such as mind maps, flow diagrams, or even word trees. Or there's wordles, process flows, but that's enough names. Don't get hung up on the terminology in this new and evolving area. The key thing is to see which ideas and techniques work for you. Indeed, you can and should just pick and mix techniques if it seems useful. Tip: the process of constructing mind maps and other kinds of concept charts hinges on using nodes and links. The nodes are represented as circles or squares or other shapes and stand for ideas and information. The lines connecting the nodes are the links, and these are the defining relationships. By connecting information like this, you are actually making knowledge explicit. In other words, knowledge is dragged from the subconscious and put on paper in plain black and white, or gorgeous colors. When you create concept charts, you not only become aware of what you already know, but are also able, as a result, to modify and build upon it. Professors take the term nodes from mathematics, where a node is a point in a network at which lines intersect, branch, or terminate. Concept charts are networks made up of those nodes and links. Tip: to discover the history of producing concept charts, check out the nearby sidebar, How It All Got Started. The crucial point to bear in mind is that two nodes plus a connecting link represent a true statement. Remember that, and you can't go wrong. How It All Got Started. Joseph D. Novak, a professor of education and biological sciences at Cornell University in the 1970s, developed the idea of concept charts as a means of representing scientific issues with his students, but always claimed that the approach has its roots in a broader philosophy known as constructivism. Very simply, the idea that people actively construct their understandings of the world. A very important related idea is that in constructing their theories, people have to build upon what they know, or at least think that they know already. Joe Novak taught students as young as 6 years old to make concept charts. One he liked particularly involved the question, "What is water?" and another was, "What causes the seasons?" My concept chart for water, see Figure 7-3, which can be found in the print and e-book versions of this book, is a simplified version of his, which was supposedly used with primary school children. But if so, I don't think the children had much input into the making of the chart. It includes links indicating that the movement of molecules explain the different physical states of water. No one seems to have noticed that at age 6, children don't really understand the molecular structure of matter. Another oddity, which I have accurately reflected in simplifying from his original chart, is that the concept water is both at the top of the hierarchy and at the bottom. When the founding father of the technique contradicts himself like that, you know that you don't need to take any expert's word on the correct way to do concept charts too literally. Novak's book argues the following. The important single factor influencing learning is what the learner already knows. David Ausbell, U.S. professor. For almost a century, educational theory and practice have been influenced by the view of behavioral psychologists that learning is synonymous with behavior change. In this book, the authors argue for the practical importance of an alternative view, that learning is synonymous with a change in the meaning of experience. They develop their theory of the conceptual nature of knowledge and describe classroom-tested strategies for helping students to construct new and more powerful meanings and to integrate thinking, feeling, and acting. In their research, they have found consistently that standard educational practices that do not lead learners to grasp the meaning of tasks usually fail to give them confidence in their abilities. It is necessary to understand why and how new information is related to what one already knows. Joe Novak, Learning How to Learn, 1984. Minding Out for Mind Maps. A mind map is a particular kind of concept chart that usually has one term or concept as its focus. The aim is to literally map out your thoughts, using associations, connections, and triggers to stimulate further ideas. But how do schematics like these work? Most of the time, whether speaking or writing, people present information in a linear sequence. They have to because people can't read or listen to two things at once. The competing information becomes a jumble. But in diagrams, the rules change. Suddenly, information can be presented in ways that are much more in tune with the way the brain functions, by making multiple connections and comparisons simultaneously. In a mind map, for example, information is structured in a radiant rather than linear manner, as shown in Figure 7-1, which can be found in the print and e-book versions of this book. Here, the core idea transport generates 4 subdivisions, which in turn prompt a whole range of specific examples. Tip: researchers have long known that the brain likes to work on the basis of association, and it connects every idea, memory, or piece of information to tens, hundreds, and even thousands of other ideas and concepts. Mind maps are said to reflect the way the brain is wired to automatically associate words and concepts with one another, or a new experience with a recent experience. When is a concept not a concept? Don't worry about the term concept chart. After all, what is a concept? Is water a concept? Is learning a concept? You can see that most of the distinctions offered by all the different kinds of diagrams used to illustrate or represent processes and ideas are supplying spurious precision in an area that is actually pretty vague. Indeed, the definitions are often contradictory. Just choose the style that suits you best, or pick out elements from the range of charts available, and use them wherever and whenever they seem to you to be useful, and definitely not otherwise. The chart is a tool for developing and communicating ideas, not an end in itself. Counting on concept charts. Concept charts, sometimes also called concept maps, have a slightly different aim than mind maps. As you may guess from the name, these diagrams depict suggested relationships between concepts. As such, they prove useful in the soft social sciences, such as psychology, sociology, and philosophy, for marketing experts' presentations, for hard-nosed designers, engineers, and technical writers, and for countless other tasks to present, organize, and structure factual information. And that's not even to get into the notion of the way information flows around the charts. See the next section. Don't let the seemingly obscure distinctions that the different names imply intimidate you into not using the tools as you like. And check out the nearby sidebar, When is a concept not a concept? Following links and going with the flow. Remember, by convention, mind maps and other kinds of concept charts usually represent ideas and information in little boxes or circles, or even little thought clouds, which are connected by lines indicating the links. Sometimes these linking lines can be represented as arrows, reflecting the supposed direction of causation, the flow of the process being represented. Figure 7-2 shows the kind of concept chart that green activists may create at protest camps. Here, the arrows tell a causal story. Building the road led to the pollution and to the car accidents, which led to cyclists deciding to drive to work instead. Warning. Notice how the arrows in the figure serve to make an argument, but also that a chart maker could choose to direct them very differently. In fact, a more accurate flowchart would be one showing all the feedback effects of certain decisions in transport policy. For example, how more cars being used also means more roads are built. This aspect could be shown with a bidirectional arrow, or by not using an arrow at all, just a line. On the other hand, to the extent that fewer buses would be wheezing round the streets and so on, less public transport could mean less pollution and more walking. But arrows for this possibility aren't included. Diagrams soon get hard to follow if too many factors are included. Remember, in practice, a flowchart requires a lot of careful selection of which elements to represent. In this sense, the charts aren't seeking to show the whole truth, just to argue a point or theory. Tip. Yet, curiously, people tend to believe charts more readily than mere words. Therefore, critical thinkers need to be as skeptical of charts and diagrams as of any other form of communication. Take a look at the concept chart for water in Figure 7-3. Since water is in all living things, Figure 7-3 shows a nice solid line connecting the two. However, no plant cells grow in animals, and so there is no line between these two nodes, animal cells and plant cells. Simple, but effective. Putting graphical tools to use. At the start of this chapter, I promised to show you how to put graphical tools to meaningful use in a critical thinking context. Well, this is that practical get your hands dirty section. Choosing the right chart arrangement. Remember, you can select from 3 kinds of concept maps, but remember, don't get too hung up on the distinctions, let alone the names. Spider. This chart is the easiest one to draw. It starts with the core concept at the center with other ideas and connections radiating out. Refer to Figure 7-1. Mind maps are essentially spider charts. Hierarchical diagrams. These often also branch out, but with a lot of categories at the bottom and just the one at the top. Refer to Figure 7-3 on water. Various kinds of flowcharts. The key characteristic of these, is that information flows around the chart, with the focus often more on this flow than on the concepts in the nodes. Check out the later section, Adding Movement to Your Diagrams by Drawing Flowcharts. Some flowcharts specify where things start, inputs into the system, and where they can end, the outputs. Others may have no start or end points, but describe the flow in terms of self-contained cycles. Refer to Figure 7-2 on roads for an example. Tip: you can rough out concept maps using those sticky yellow notes. Then you can easily reorder the material as your ideas about its proper arrangement develop. Some people think that labeling the links, the lines between the concepts, is very important. But I'm not so sure, and it's certainly not universally agreed. Some maps use labels such as includes or with. For example, in a map looking at geology, you may be told that metal includes gold and includes silver, which seems to distract from the way the map is supposed to reflect the brain's architecture, and to have lost the good original principle that instead of thinking only in words, people should try to visualize multiple relationships and connections. Additionally, labeling the lines requires people to go back to thinking linearly. If, however, your chart is pretty formal, perhaps representing a process, with only one correct way possible to read it, the labels are useful. Indeed, they're an essential part of the chart's information. Remember, a similar you win some, you lose some consideration comes with the notion of organizing concept charts so as to have the more general, abstract concepts at the top of the page, or whiteboard, and more specific, less inclusive concepts at the bottom, like the hierarchical charts I introduce at the start of this section. Joe Novak, who popularized the technique originally, thought this arrangement was very important. See the earlier sidebar, How It All Got Started. Developing simple concept charts. Basically, all concept charts represent statements, just like a written description does. In particular, two nodes plus a connecting line represent a proposition, a statement that's supposed to be true. For example, the concept chart in Figure 7-4, which can be found in the print and e-book versions of this book, is one way to represent the sentence, "Grass is green." But a more complex and more useful example is to try to represent a sentence such as, "Red berries are yummy." This process of adding new factors is well represented here. See Figure 7-5. Now, red berries, like strawberries, are yummy. Raspberries are yummy. Hawthorn berries can be used in jams and wines. But other kinds of red berries, such as yew and holly, aren't yummy. These maps help both teachers and students to focus on the key ideas, concepts, needed in any given area of inquiry, like how not to get poisoned when out on nature rambles. Using maps and charts in the real world. Concept maps have their roots in the sciences and are widely used today in fields such as software design and engineering. But they're also used in many business and, of course, educational contexts. Some charts are really too personal and idiosyncratic to say very much to anyone except the person who designed them. But others are precise and unambiguous blueprints. Such a wide spectrum of charts and maps exist that finding any features that they all share is difficult. Remember, one useful distinction, certainly one that's often claimed, is that a well-made concept chart grows within a context frame, typically an implied argument or question, whereas a mind map often has only branches radiating out from a central word or picture. your chance to use some clip art representing an idea or concept. Because concept charts are constructed to reflect organization of the declarative memory system, a technical term used to describe things such as facts and knowledge that can be actively recalled and, well, declared, such as Paris is the capital of France, they're often claimed to facilitate analysis and evaluation of information people already have. The other kind of memory is called non-declarative or procedural memory and refers to unconscious memories, such as skills like riding a bicycle or how to construct sentences correctly. Appreciating the different styles of concept charts and mind maps. When you're producing mind maps and concept charts, you need to be aware of how different graphical techniques suit the different issues, questions, or problems. Concept maps and topic maps, to add another term for something very similar, both allow people to connect concepts or topics via a graphical representation, and both can be contrasted with the particular idea of mind mapping, which is often restricted to radial hierarchies, those spider diagrams, and tree structures. Topic maps are intended to be easily navigated and quickly indicate information, like a well-designed index at the back of a book. However, out of all the various schema and techniques for visualizing ideas, processes, organizations, concept mapping is unique in its philosophical basis. This, according to its inventor, Joe Novak, makes concepts and propositions composed of concepts the central elements in the structure of knowledge and construction of meaning. Another contrast between the more formal kinds of concept mapping and mind mapping is the speed and spontaneity possible when creating the latter. A mind map typically reflects what people think about a single topic and can focus group brainstorming, something I discuss further in the later section, Conjuring Up Ideas with Brainstorming. The more formal kind of concept chart is rather harder to create, but when done, it can provide more insights. It's also a kind of map, in the sense of something that tells you how things relate and how one thing connects to another, but it provides a system view of a real or an abstract concept. Graphically, concept charts can become complicated and cease to follow any obvious spatial logic as multiple hubs and clusters are created. For example, one part may be unimportant but take up a lot of space, and another important element may be represented by just a single word or image. In this sense, mind maps that fix on a single conceptual center and then radiate out have a nice kind of visual logic built in. Tip: concept mapping can be a first step in constructing a framework for organizing knowledge, a process sometimes given the fancy name ontology building, or used to represent formal, as in formally expressed, arguments in logic. As such, you'll find concept charts particularly useful in education and business contexts. You might also consider creating formalized concept charts using special software. Adding movement to your diagrams by drawing flowcharts. A common type of technical diagram is a flowchart, which in the broad sense is a concept map. However, the term usually means a pretty precise kind of schematic representation of a sequence of operations, as in a manufacturing process or computer program. Most flowcharts are made up of three main types of symbols. Elongated circles. These signify the start or end of a process. Rectangles. These show instructions or actions. Diamonds. These show decisions that must be made. Within each symbol, you write down what the symbol represents, the start or finish of the process, the action to be taken, or the decision to be made. Finally, symbols are connected to one another by arrows, showing the flow of the process. You can see the similarities between these kinds of technical diagrams and rather more free-spirited efforts in the social sciences when you consider the ways that technical flowcharts are used. These usually include defining and analyzing a process, providing a step-by-step picture of a process for later analysis, discussion, or communication, standardizing a process, looking for ways to improve processes. Why not practice with a simple chart on, say, how to read a book while thinking critically? 1. Start the flowchart by drawing a circle and labeling it Start. 2. Move to the first action or question and draw a rectangle or a diamond, depending on whether or not a decision is required at this stage. 3. Write the action or question inside it and draw an arrow from the start symbol to this shape. 4. Work through your whole process, showing actions and decisions appropriately in the order they occur, and linking these together using arrows to show the flow of the process. Where a decision needs to be made, draw arrows allowing for every possible outcome from the decision diamond. These arrows are usually labeled with the outcome. At the end of the process is a circle labeled Finish. 5. Test run your flowchart, working from step to step, asking yourself if you have correctly represented the sequence of actions and decisions involved in the process. And then, if you're looking to improve the process, think about whether work is duplicated or whether other steps should be added. For example, you may use your chart to encourage people to start by scanning the book, checking the contents page, or even scanning the index. Tip: it's actually very easy to sort of doze off while reading, this book included. So the kinds of questions you might add to your flowchart are ones like, have you already read this section? Depending on the answer to that, options might be start taking notes or come up with your own questions about the content. Another question might be, have you any intention of actually doing any of the things mentioned? From this question, decision options might be, think about your goals, or even, no, but I like to imagine doing them. Tip: flowcharts can quickly become so complicated that you can't show them on one piece of paper. Instead, you can use connectors, shown as numbered circles, where the flow moves off one page and where it moves on to another. By using the same number for the off-page connector and the on-page connector, you show that the flow is moving from one page to the next. The process of physically splitting up your diagram can also imply a way to mentally split up a complex issue or process, enabling you, or the people you are sharing the idea with, to concentrate on particular parts of it better. You can also develop a main chart with major branching concepts, but include only what fits on one page. Then create more detailed pages of each of the major concepts with sub-branches that branch off into more detail. This could be a better way to organize a large subject, concept, with a few major branches or sub-branches. Considering other thinking tools. The graphical tools I discuss in the preceding section aren't the only ones available to you. Here, I cover dump lists, summarizing, brainstorming, meta-thinking, and triangulation. You can think of these tools as organizational strategies for the contents of your brain. Dump lists are a way of organizing information in your head. Summarizing and meta-thinking are about making sense of things you read or hear, and triangulation is about checking the quality of what you have come up with. Brainstorming is primarily a tool for generating ideas, but can also be used to help sort and analyze information. Emptying your head with a dump list. The truth is that coming up with material is much easier than analyzing and selecting the key ideas within it. Dump lists are a powerful but neglected tool in thinking. Basically, you just empty onto a page everything swirling around in your head on a particular topic or issue. Say you're wondering about a practical problem that presumably has a practical solution, such as why all the plants in your house always die, but you've not yet been able to find the answer. Try a bit of critical thinking. Start by dumping all the thoughts in your head that seem like they might be relevant, even if at the moment you're not sure how or why. In my houseplants scenario, the dump might look like this. Lots of my houseplants dry out. Nothing seems to grow. The leaves of my plants go brown and then drop off. Even the cactus has a kind of white fungus. Maybe I should water my plants more. Maybe my plants need plant food. Maybe the rooms are too drafty. Maybe the plants aren't getting enough sun. The next step is to do some sifting, sorting, and maybe simplifying of the list. Could some of the points usefully be grouped together as concerning the same sort of thing? Is there any one step that would solve the problem? Perhaps you can get rid of things that are easy to solve. For example, the problem "the soil has dried out" implies the solution "I should water the plants." On the other hand, the problem "even the cactus has a kind of white fungus" seems to indicate that maybe too little water is not the problem. So beware of crossing out things on your list too soon, because oversimplification of an issue can lead to errors later. Tip: a safer approach with a dump list is to add priority numbers, a simple way to arrange your jumble of thoughts into a hierarchy with the most urgent steps, say, or the most practical ones given a higher priority. Sifting for gold. Summarizing. Summarizing is such a useful skill. It involves separating the wheat from the chaff, the golden nuggets from the heaps of spoil, the key words and phrases from the blah blah blah. Put more simply, summarizing is a key life tool that enables you to organize and make sense of the world around you. Here are some simple techniques that can help you do it effectively. Plus, it's a great chance to use those highlighter pens that come in so many more shades than fluorescent yellow. All you do is use your favorite highlighter to mark up the key points in a piece of text. If you find you've marked up several paragraphs, maybe you aren't being quite critical enough. Not summarizing, but, well, highlighting. So be strict with yourself. Mark up only the key idea in any paragraph, and highlight only elements from the most important paragraphs. Here's a simple exercise. Summarize the last 2 paragraphs. Remember, summarizing is about capturing the main ideas of a text or lecture in a greatly reduced space. Academic study is all about making use of the ideas of other people, not their words. Summaries help you do the former and not the latter. But when you do find a phrase in the original text that's particularly striking and really can't be summed up without losing something, do use the author's exact words. Highlight them. If you make a note, make sure that you put quotation marks around the words and indicate the source. Otherwise, that fine phrase may turn up later, rather disgracefully, unattributed in your work. Warning. In theory, A well-structured essay or document already contains the key ideas in a summary, but don't believe that a passage is a summary just because someone writes "so to sum up," or even puts the word summary, or maybe conclusion in big letters above it. After all, alas, the skills of summary writing are by no means universal. Plus, what that person is interested in may not be what you're interested in. Summaries reflect their interests, not yours. Tip: you can also organize your notes in new ways on little cards, or these days as computer files, or even on computer sites, such as wikis, that let you easily create and organize pages, perhaps providing an overview of a topic on one and subtopics on others, maybe using colors to aid categorizing. Conjuring up ideas with brainstorming. Brainstorming is the name given to the fairly obvious technique of quickly jotting lots of ideas down in response to a question, or even simply a concept. You can brainstorm on your own, but the real advantages of the technique come when you're in a group, because that's where other people's ideas can spark new ones among other members of the group. Brainstorm, mind monsoon, cranial blizzard. Brainstorming was popularized by Alex Fikney Osborne in a 1953 book called Applied Imagination: Principles and Procedures of Creative Problem Solving. He got the idea from where he worked, which was an advertising agency. You can imagine how the executives sat around a whiteboard while someone wrote up a word such as coffee, and everyone shouted out word associations: aroma, Brazil, going to work in the early morning. No one censored the suggestions. Instead, they were taken as was, noted on the board, and only arranged, highlighted, or deleted later. The claim of the method's supporters is that brainstorming allows a group to think collectively and build on each other's ideas. Conducting a group brainstorm can also create a buzz, something that can be absent when you work on your own. But brainstorming can be a bit of a lowest common denominator exercise too, by which I mean that the idea that everyone likes is not the best one, but only the one that everyone shares. Groupthink on steroids. Worse, the group may not recognize a good idea just because it is a bit different or novel. So how you brainstorm is important. Groups use many different ways to capture the ideas of a brainstorming session, but here are two of the biggies, both of which are led by a coordinator. Scribe. Coordinators, the scribes, not so much write, which can be a cumbersome and inefficient process, but rather capture on the board all the ideas that team members call out. They try to sum up the idea in an appropriate way, regardless of their own feelings about the merits or demerits of the idea. All in. During these sessions, team members can write on the board their ideas just as they come, or perhaps instead verbally share them with the group. The ever-useful yellow sticky notes can be brought out so that everyone can write their ideas down and then stick them on the board. The attitude and abilities of the coordinators are vital to a successful brainstorm. And although not everyone automatically has the right stuff, some principles certainly can be adopted. The person leading the brainstorm needs to be enthusiastic and encouraging. Adding fun constraints can help spark new ideas. For example, if a group is wondering about, say, how to revitalize inner cities, perhaps a bit of a downer for an early morning session, the coordinators can constrain the issue by asking instead, if you had to improve life for people in inner-city Liverpool with just one big project, what would it be? Now, harvest that brainstorm. At a session, act as the coordinator and focus on the ideas that the people seem most excited, amused, or intrigued by. Don't judge the things by thinking that they aren't practical. An impractical idea may still have within it something usable. And remember to involve groups, of course, in the weeding. One way of increasing participation in this stage is by voting. Hey, sticky notes prove their usefulness yet again. Ascending the heights, meta-thinking. Concept charts require the higher skills in Benjamin Bloom's famous taxonomy, from mere recall at level 1 to complex evaluation at level 6. Check out Chapter 8 for details. In fact, Joe Novak, see the earlier sidebar, How It All Got Started, says it requires students to use all of the levels at once. But meta means above or higher, so that meta-thinking indicates taking an overview, view from above, and represents a higher, more critical level of thinking skill. To be critical often requires a move from ground level to meta-level thinking. Remember, meta-level understanding asks why such a particular strategy is the one to use. Without this, learning new strategies is useless because you don't know when they're appropriate. The contemporary thinking skills guru Edward de Bono, who invented the term lateral thinking and wrote a book called 6 Thinking Hats, calls meta-thinking blue hat thinking, summing it up as thinking about thinking. In his terms, blue hat thinking focuses on how to manage the thinking process, checking its focus, setting out the next steps, and creating action plans. For instance, if a sports team is discussing how to win the next game, the coach likely automatically adopts the blue hat style, reminding the players that the focus is on how to win the next game against the Brickworks 11. The agreed next steps the team has identified include practicing penalties, because the Brickworks team commits a lot of fouls and maybe will give a penalty away. The longer-term aim is how to build on the expected victory over the Brickworks 11 and get the team promotion to the Grimsby West League. Trying out triangulation. How to triangulate the data to stop the roof from falling in. That's a metaphor, by the way, which seemed appropriate to me because most roofs contain wooden triangles, which literally stop them falling in. Roofers know that triangles are very strong structures, and perhaps this is the best way to think of the activity that academics have in mind when they use the term triangulation to describe a methodological tool used when constructing essays and arguments across all areas of knowledge, instead of the purer mathematical sense, which sees them used for many purposes, including surveying, navigation, metrology, astronomy, and so on. The math of triangles to measure things goes back a long time, certainly to the 6th century BC, when the Greek philosopher Thales is said to have used triangulation to calculate the height of the pyramids. In critical thinking, however, triangulation is about running a check on your work and strengthening your conclusions, and the term was only introduced in academia in the 1960s. Remember, an argument is much more convincing if 3 people have independently reached the same conclusion by different routes. The same reasoning applies when just one person, you, demonstrates a point using 3 different approaches. But despite what the song says, nothing is magic about the number 3. 2 arguments for a point, or different perspectives on an issue, are better than 1, and 4 or 5 are good too. Technical stuff. Both qualitative and quantitative researchers use the triangulation method and get different things from it. Qualitative researchers. People whose research involves judgments more than mere measurements often use it as a kind of double check on their background assumptions. When triangulation throws up inconsistencies, these researchers, who are concerned with human perspectives, often see the differences as an opportunity to uncover deeper meaning in their data. Quantitative researchers. These more scientific number-crunching researchers may be more interested in spotting flaws in their methodology and usually just want all their studies to arrive at the same figures. They're inclined to consider differences as very bad news, as weakening the evidence. Different kinds of triangles. Social scientists use various methods of triangulation, but they all ultimately aim to do the same thing, to make research conclusions more persuasive. Data triangulation. The most common kind is the technique of using different sources of information in a study. In the case of an investigation into a new town square, for example, rather than just one-time measurement of public opinion, consideration of the different perspectives is obviously a good idea. For example, the views of tourists, local residents, and local shopkeepers. During the analysis stage, feedback from these stakeholder groups can be compared not only to establish areas of agreement, but also to reveal areas of divergence. Investigator triangulation. This simply means involving several different observers, interviewers, or data analysts. Take economic statistics, for example. You can easily find 3 economists who draw very different conclusions from the same data. Environmental triangulation. Suppose you want to see whether new cycle lanes have had a significant effect on people's use of bicycles in a holiday resort. You'll produce a more compelling study if you triangulate the data by taking your measurements and interviewing your participants at several times of the year, not just at peak holiday season, but also in the middle of winter. Theory triangulation. When expert opinion on a matter is known to be grouped into warring camps, it makes good sense to offer the data to someone from each perspective to see what they make of it. Again, taking economics. Suppose you're interested in looking at the effects of high interest rates on business investment. You may find differences between the views of the Marxists and free marketers, or between Keynesian and Chicago schoolers, or whatever. It's also possible, to some extent, that one researcher could try to adopt these different perspectives alone without necessarily needing to find different people. Methodological triangulation. This approach is very important and involves using several methods to study a question. For example, results from surveys, focus groups, and interviews can be compared to see whether similar results are being found. If the conclusions from each of the methods are the same, validity is established. In my own experience as a researcher into an educational policy, increasing the use of computers in school classrooms, I used 3 methods: interviews with teachers and children, classroom observation, and analysis of official documents to assess the changes. These are all qualitative measures, but I also gathered quantitative data using questionnaires. I could even have used figures from things such as exam results or even classroom attendance levels. When all the findings from all the methods point at similar conclusions, the methodological triangulation has helped to establish the validity of the research. Real-life triangles. One example of the correct use of triangulation, in this case methodological triangulation, See the nearby sidebar Different Kinds of Triangles for an explanation, comes from research looking at the needs and experiences of relatives when a loved one is very ill or dying in the hospital. Gail Burr found that two very different impressions of family needs came about depending on whether the relatives were interviewed in person or merely filled out questionnaires. The relatives who were interviewed found talking to the researcher about their experiences therapeutic, and thus were inclined to be positive. But those who only filled out questionnaires used them to communicate their frustrations. Both perspectives were valid, but the deeper insight came from combining the research techniques. Tip: a nice way to visualize triangulation is given in a well-known book on research methods by Matthew Miles and Michael Huberman. They say that doctors, detectives, and even your local garage mechanic automatically use the technique in order to increase the likelihood that their diagnosis, whether concerning an illness, a burglary, or a broken-down car, is right. When the detective amasses fingerprints, hair samples, alibis, eyewitness accounts, and the like, a case is being made that presumably fits one suspect far better than others. Diagnosis of engine failure or chest pain follows a similar pattern. All the signs presumably point to the same conclusions. Note the importance of having different kinds of measurement, which provide repeated verification. Matthew Miles and Michael Huberman, Qualitative Data Analysis, an expanded sourcebook, 2nd edition, Sage Publications, 1994. Denzin's Three-Sided Methods. Norman Denzin wrote 2 books about alcoholics and hospitals that some people in the sociological research business think are hugely underrated classics, on a par with the writings of the 19th century sociologist Emil Durkheim. Whether Denzin really is a great or not shouldn't matter to critical thinkers, but his books certainly contain important messages about a profound social malaise in America, which he attributes to a white male culture. Denzin's study follows in the footsteps of Durkheim, whose research into the thinking of people who committed suicide gave insights into the role of social groupings in society, and also the work of German philosopher Max Weber, whose investigation of the links between the Protestant religion and business suggested that religions were shaped by economic priorities. Denzin argues that the story of alcohol is intricately connected to the story of American society, because alcohol is a key link between individuals and the social structure. Alcoholics, he says, use alcohol to try to assert their place in the world and to control the world. Of course, in extreme cases, they're the ones who lose control to alcohol. Crystallizing ideas. Tip: the notion of triangulation has been popular in social and educational research for decades. Over the years, however, the term has been used in so many different ways that it no longer seems to have a specific meaning and use. Many studies claiming to use triangulation share little resemblance. Margaret Sandolowski, a professor of health science, has even complained that having too much meaning, the word triangulation has no meaning at all. Seeing this, some researchers have proposed that, in the social sciences at least, the term triangulation should be replaced by crystallization, on the grounds that crystals are a better metaphor for what's really going on. In the words of 2 sociologists, Laurel Richardson and Elizabeth Adams St. Pierre, because a triangle is a rigid, fixed, 2-dimensional object, the term implies a certain attempt to impose rigid, 2-dimensional meanings on complex issues. Much better, they argue, to use crystals because these are prisms that reflect externalities and refract within themselves, creating different colors, patterns, and arrays casting off in different directions. What we see depends on our angle of repose, not triangulation, but crystallization. Certainly, if you intend to use triangulation to make your arguments more persuasive, you have to be clear about which form you're using and why and how you intend to do so. Now, because Denson is interested in the inner world of the alcoholic and in the social structures and the real world surrounding them, he asks the reader to think of two researchers studying someone who's suffered mental illness and is in the hospital. Each of the researchers chooses different methods. One opts for a survey, while the other uses participant observation. These methods lead to differences in the questions they ask and the observations they make. In addition, the findings are colored by the researchers' different personalities, biographies, and biases, which influence the nature of their interactions with the social world. Each uncovers different aspects of what takes place in the hospital, but neither can reveal it all. Therefore, Denson concludes that to get as full and accurate a picture as possible, researchers must use more than one strategy. Answers to Chapter 7's exercises. Check out the following answers to this chapter's exercises. The plant problem. Here's my approach to addressing this problem. Problems. Plants dry out, leaves go brown and then drop off. Solution: more water. The cactus. A special case, separated out. Summarizing exercise. The key ideas here are summarizing is a really useful skill that helps you make sense of things. Yes, I know it's repetitive, but summaries are practical, not elegant. And use highlighters to mark up key points. Chapter 8. Constructing Knowledge. Information Hierarchies. In this chapter, seeing how people handle new information. Thinking deeper about the knowledge pyramid. Resisting the temptation to give up learning. The central theme of this chapter is that many stages of information processing lie behind every piece of knowledge. To illustrate the process of building knowledge, this chapter uses the analogy of constructing a pyramid. I describe climbing the knowledge pyramid by checking out the building blocks of knowledge, data, and information. I also discuss the elegant and definitely pyramid-shaped ideas of Benjamin Bloom, as well as another American professor, Calvin Taylor, who extended Bloom's ideas to emphasize the importance of creativity. In addition, I look at how to get and keep yourself motivated on that climb to the top of the thinking pyramid. Although some of this chapter may seem a bit theoretical and abstract, bear with me. These ideas are in fact highly practical in terms of developing your critical thinking skills. So put on stout boots, pack some sandwiches, and fill a water bottle, because you have a steep but rewarding climb ahead. Building the Knowledge Pyramid. Philosophy starts with the question, what is knowledge? But this section trumps that by going back a stage and asking, what is data? This extra step is definitely useful because knowledge is constructed from smaller building blocks called data, or sometimes information. In this section, I pin down the three crucial terms, data, information, and knowledge, and describe how they're related. I discuss them in relation to education and learning and warn about when they can cause problems. Remember, One of the key insights of this chapter is that what you know is less important than how you know it. That sounds a bit cryptic, but it boils down to the difference between two types of thinking: lots and HOTS. Low-order thinking skills concerns simple observations and memorization and recall of facts and figures. Concrete reasoning like this is the foundation of the next, more elaborate type of thinking. High-order thinking skills. This is abstract reasoning that involves cognitive processes such as analysis, evaluation, and synthesis. It concerns relationships and can even handle things that don't exist, at least not yet. It sounds grand, but nonetheless it can't take place without the first type of thinking. Low and high. Knowledge is all about hierarchies. Now, I know that anything hierarchical sounds rather snooty, but it doesn't have to be that way. People certainly need both types of thinking, low level and high level, and the hierarchy isn't one of value. But nature first makes people experts in practical, concrete thinking, and because you have to train your mind before you can do the abstract kind, a premium applies to the ability to think at the higher level. Viewing the connections between data and information. Part of the difficulty in this area is the lack of apparent agreement on the meaning of the terms data, information, and knowledge. Some dictionaries say that knowledge is the same thing as information, but that data is quite different, whereas others say that data is the same thing as information, but that knowledge is quite different. That such fundamental notions can be so loosely defined is pretty amazing. Critical thinkers, of course, can't afford to be so lax. Remember, even professors and other experts often use the words interchangeably as if they're the same thing. In fact, they're quite different. Their relationship is hierarchical, and the arrangement is like a pyramid. Data. At the bottom of the hierarchy is data, which consists of facts and figures. Information. In the middle of the hierarchy is information, which comprises data that has been organized to a greater or lesser extent. Knowledge. At the top of the hierarchy sits knowledge, which is certainly like information but rather purer, grander, and certainly rather harder to find. Another way of looking at the relationship between information and data is that the key factor is the degree to which items of data are interlinked. Take a look at Figure 8-1. In the left-hand panel, data consists of dots, showing each bit of data in splendid isolation. But in the middle panel, the data has been made sense of and connected up. This network of connections is information. Finally, the right-hand panel presents a possible view of knowledge as information understood as part of a broader context. The information is further organized within collective, socially constructed or linked structures. Complex relationships of cause and effect, for example. Joining the data dots to create information. John Dewey, a professor of education in the United States and something of a progressive, offers 3 principles of education which concern the importance of the relationship between facts, data, and how people turn them into information. Read through, and then test your skills of comprehension on the following argument from Professor Dewey concerning democratic education. Try to reduce it to just 1 line, and then compare what you extract to my note at the end of this chapter. If you like, you can find the whole article by visiting thephilosopher.co.uk and typing Dewey in the search box. 1. The human mind does not learn in a vacuum. The facts presented for learning to be grasped must have some relation to the previous experience of the individual or to his present needs. Learning proceeds from the concrete to the general, not from the general to the particular. 2. Every individual is a little different from every other individual, not alone in his general capacity and character. The differences extend to rather minute abilities and characteristics, and no amount of discipline will eradicate them. The obvious conclusion of this is that uniform methods cannot possibly produce uniform results in education, that the more we wish to come to making everyone alike, the more varied and individualized must the methods be. 3. Individual effort is impossible without individual interest. There can be no such thing as a subject which in and by itself will furnish training for every mind. If work is not in itself interesting to the individual, he cannot put his best efforts into it. However hard he may work at it, the effort does not go into the accomplishment of the work, but is largely dissipated in a moral and emotional struggle to keep the attention where it is not held. John Dewey, The Philosopher, 1934. Another question to ask yourself is, what would this argument mean in practice? In his book, Democracy and Education, Dewey gives an example of a man entering a shop showroom full of different chairs. He says that the man's past experiences will help him choose the chair that best suits him, and the more experience he has with various chairs, the better prepared he will be for selecting the correct one. Everything he knows about chairs comes from the connections that he's created in his mind in the past, such as how comfortable they are to sit on, how difficult to clean, how strong, and so on. These connections form the content of his knowledge about chairs. This kind of content is what enables people to make the new connections needed in new situations. We respond to the new experiences, connections, and not simply to the immediate occurrence. Thus, our attitude to it is much freer. We may approach it, so to speak, from any one of the angles provided by its connections. We can bring into play, as we deem wise, any of the habits appropriate to any one of the connected objects. Thus, we get at a new event indirectly instead of immediately, by invention, ingenuity, resourcefulness. An ideally perfect knowledge would represent such a network of interconnections that any past experience would offer a point of advantage from which to get at the problem presented in a new experience. John Dewey, Democracy and Education, 1923. So, Dewey says that information, let alone items of knowledge, can't really be considered in isolation. Nonetheless, there is some sort of difference worth making. The following example illustrates the distinction in a nice, simple case. Suppose that I measure rainfall in my garden for 2 years and write the figures into a notebook. The list of figures comprises the data. I then make a chart out of the data and send it to my local paper, along with a letter explaining that my research shows that it has been a very wet summer. Both the chart and the view expressed in the letter are kinds of information, ways of processing the data. Remember, data just is. Data is facts that can't be argued about, although, to extend my example, my rain gauge may be faulty. Nonetheless, the list of readings I have is my data, for better or worse. As soon as I turn them into a chart, that is, organize the data, put it under a heading and make it send a message, the data becomes information. That's also what Carl Hempel means when he says that the transition from data to theory requires a bit of creative imagination. See Chapter 6. Information is built up out of data from facts. The facts don't have to be statistical ones like rain measurements, of course. They can come from all kinds of experience, from listening to music to watching the sunset. Qualitative data is descriptive information. Check out the following section, Social Media Sifting Disinformation, for the story of what happened when Twitter/X's data engineers tried to separate facts from comment by combining computer power with the so-called wisdom of the crowd. Social media sifting disinformation. These days, a lot of people get their information, especially on breaking news, from social media on the internet. These are sites like Facebook and Twitter, or X, as its new owner, Elon Musk, has rather confusingly rebranded it. Twitter/X is very influential precisely because a lot of the information shared on it is breaking news from people like journalists and eyewitnesses. Influential posts include eyewitness accounts of coups and revolutions. But social media is just as happy investigating sports and culture. In 2014, the Germany versus Brazil World Cup soccer match, which Germany won by 7-1, by the way, became the most talked about sports game on Twitter ever. How many people talked about it? Well, there were over 35 million tweets about the match. 4 million a goal. You may have heard about the Russian invasion of Ukraine, a war in which, at the time of writing, 500,000 Ukrainian and Russian soldiers have been wounded or killed, and in which the United Nations recently calculated that at least 10,000 civilians have died. But just before the war started, the Russian embassy tweeted that the truth was that there were no plans to invade, and it was rather all an attempt by the United States to stir things up. Plenty of people repeated the Russian claims too. Even after actual Russian missile strikes on Kyiv and other Ukrainian cities, some Twitter accounts posted that Ukraine was fabricating civilian casualties. One account, &NE_NU_CHE, shared a video of a man standing in front of rows of grim-looking body bags that appeared to be filled with corpses. But as the man spoke to the camera, one of the encased bodies behind him lifted its arms to stop the top of the bag from blowing away. The video was offered to disprove the Western claims about the war, and it certainly seemed to. Only later did it turn out that the film had nothing to do with Ukraine, but was actually taken from an Austrian TV report about a climate change demonstration held in Vienna in February. Nonetheless, for the average reader on the site, it was hard to know who or what to believe. Birdwatch. Which brings me to Birdwatch and the attempts by Twitter to discourage the deliberate spreading of misinformation for political or maybe commercial ends. The idea behind Birdwatch, or Community Notes, as it is now more prosaically called, is that the community of Twitter users can add helpful context to posts and keep people better informed. A good note follows the same principles as a critical thinker might by citing high-quality sources, being easy to understand, directly addressing the controversial claim, providing important context, and finally, it is expressed in neutral or unbiased language. These are all good principles, but how to make sure people follow them? Here, Twitter brings in the element of the wisdom of the crowd. As the site itself puts it, the idea is that the more people that participate, the better. Participation is not left to chance, however. Those who have been accepted into the Community Notes program can add a note to a tweet that they think is misleading or plain wrong. But the note, will not be publicly visible until several other people have independently assessed their note and judged it as helpful. And to make sure these assessments really are independent, the Twitter algorithm makes sure that notes require agreement between contributors who have disagreed in the past. The theory is that if people who typically disagree in their ratings agree that a given note is helpful, it's a good indication that the note really is helpful. Certainly, research has flagged up that social media users often have vastly different interpretations of facts or even operate on entirely different sets of facts. Two advantages of this slightly hands-off system are that the notes are seen as genuinely reflecting the community's view, rather than being some central authority, and secondly, the system can respond quickly to controversial information, rather than having to wait for the head of user content to conduct an official inquiry. But there are disadvantages too. Writing in Slate magazine in July 2023, Nitish Pahwa noted that in general, corrections with a political valence, meaning flavor, have trouble getting enough votes from an ideological diverse group, even in cases in which a political or media figure had clearly lied. And well-organized lobbies can vote down views they disagree with. Watching for errors and biases. Alas, the transition from data to information brings with it the possibility of error and bias. In the measuring rainfall scenario in an earlier section, joining the data dots to create information, for example, I could easily introduce distortions through the decisions I take for things, such as which readings to count as being in the summer and which to leave out, the scales used for the axes on my chart, or maybe even my choice of measuring equipment. Perhaps to strengthen my point, I might have been tempted to start the readings a bit later than I originally intended to avoid a dry period. For reasons such as these, someone seeing my chart could reasonably dismiss it as only my opinion. My letter to the paper certainly is, yet not, I think, the underlying data. They constitute raw and brute facts about my garden as recorded by my gauge. Here's a question for you to mull over. When I say it's been an exceptionally wet summer, is that a statement of fact or merely an opinion? Flip to the end of this chapter and compare your view with my take on this problem. Turning the knowledge hierarchy upside down. Several thinkers have adopted and adapted the knowledge hierarchy described in the preceding section, adding extra layers with particular functions to it, such as the intellectual stages of comprehension, analysis, and synthesis. And some have even inverted it. Here, I describe the key aspects of this important revising work, particularly that of Benjamin Bloom, who, despite his name, isn't one of Batman's fantastical foes. Thinking Critically with Benjamin Bloom. Benjamin Bloom was one of a group of educational psychologists in the U.S. who devised a pyramid model that they said represented different ways of learning. They made it a pyramid to show that the highest form of learning, which for them was evaluating information, was ultimately based on a much broader level of information that had just been, well, learned. Meeting Bloom's taxonomy. Bloom wanted to promote higher forms of critical thinking in education, such as the use of analysis and evaluation of material, away from teachers just drilling people into remembering facts and figures and generally learning by rote. His system is now half a century old, yet still looks pretty progressive in educational terms, which maybe tells you something about how stuck in the mud schools and colleges are as regards to what is important in education. Unlike in the no-frills economy class system, which places knowledge at the top, Bloom's taxonomy, nothing to do with creepy stuffed animals, thankfully, but a system for classifying or arranging things or concepts, starts by placing knowledge at the bottom of the heap. See Figure 8-2, which can be found in the print and ebook versions of this book. The pyramid then rises upwards through 6 levels. Here they are, with examples of each one. Level 1. Knowledge. Normally, people think of knowledge as something wonderful, even powerful. But Bloom defines knowledge simply as the remembering of previously learned material. Nothing very grand about that, which is why he puts it right at the bottom of his hierarchy of learning. An example is recalling data or information, such as knowing the names of different kinds of trees. Level 2. Comprehension. The next rung up, comprehension, is the ability to grasp the meaning of material. But this kind of understanding is low-level stuff too. An example is understanding texts, instructions, and problems, such as being able to restate something in your own words. Level 3. Application. This stage is a step up the hierarchy because it requires the ability to apply, to use, the learned material in new situations. An example would be the practical use of concepts or skills. Someone who has studied the difference between facts and inferences is able to apply this skill to certain texts in their examination of arguments. Tip. But if you just rote learn how to apply something that you've been told about, as many people remember being drilled to do in classes, this is still learning at level 1. Level 4. Analysis. Only with analysis, a word that means to take things apart, does learning require an understanding of the material. You can't rote learn how to analyze things, though I suppose you can rote learn certain steps that may help you to do it. Analyzing is, say, splitting up a text into its component parts to better see and understand its structure, perhaps to spot certain logical fallacies in someone's reasoning. Level 5. Synthesis. This level follows analysis because it refers to the ability to put information and ideas together to create something new. Creativity is involved. For example, the skills of synthesis are needed when constructing a new structure from diverse elements, or reassembling parts to create a new meaning or interpretation, such as writing an original essay using multiple sources, or designing a garden choosing from a range of possible tools and approaches. Level 6. Evaluation. This, the top level of the taxonomy, is defined as the ability to assess the value, or perhaps the usefulness, of the knowledge comprehended, applied, analyzed, and synthesized at the earlier levels. Evaluation is really the stuff teachers enjoy. Benjamin Bloom was a professor about the value of ideas or materials, whether arguments work, and even about the merits, skills, and abilities of people. A typical example could be choosing the best book when preparing to study a new subject. Tip. Bloom's taxonomy was primarily created for academic education, but it's relevant to all kinds of learning. Making knowledge flow upwards. Water can't do it, but knowledge does, or at least that's the implication of Bloom's hierarchy. The upper levels draw on the lower levels, but the lower levels can't call upon the higher levels. Remember, don't mistake this talk about different levels for something hopelessly abstract. It's all highly practical. For example, if all someone is able to do by way of research is, say, to read about something in Wikipedia and edit down to the sections that seem immediately relevant, that person has a way to go before creating something new. The person who wants to do that must at least be able to combine several sources, which requires the high-level thinking skills of synthesis. Plus, only people who can evaluate material can judge whether what they've produced is any good. In other words, only people at the top of the knowledge pyramid can write good essays. Revising that Blooming taxonomy. During the 1990s, a new group of academics who rebranded themselves as cognitive psychologists, despite evidently doing much the same thing as Bloom, including Lauren Anderson, one of Bloom's former students, updated Bloom's pyramid to, so they said, reflect new 21st century insights into how people think. The key changes were changing the names of the 6 categories from plain-speaking nouns to gerunds at each level. Gerunds are verbs turned into active nouns by adding the ing ending. You can see them in section headings throughout For Dummies books. Rearranging the hierarchy. The biggest change, see Figure 8-3, is that creating is now top of the pyramid, a skill that Bloom didn't even mention. The other changes seem to be more or less changing the style more than the substance. Other new models have also come along. One of the most interesting, proposed by 2 Australians, psychologist and novelist John Biggs and Kevin Collis, a business consultant with an interest in lateral thinking, is called the Structure of Observed Learning Outcome, SOLO taxonomy. This one consists of 5 levels. Missing the point, pre-structural. These learners don't understand the lesson or subject. I've been there. Single point, unistructural. These learners have a basic insight into the subject but only focus on one relevant aspect. Multiple unrelated points, multi-structural. These learners now focus on several relevant aspects, but these are all treated in isolation. The insights are disconnected. Intermediate, relational. At last, the different insights have become integrated. These learners have mastered their subject by being able to join all the parts together. This is where most learning stops. Logically related, extended abstract. Some learners may go one step further and be able to create new ideas based on their complete understanding of the subject. Remember, thinking that requires all the skills in Bloom's pyramid is better than thinking that requires less of them. Creativity that has a practical outcome, in other words, inventing, is supposed to exemplify this kind of everything thinking, because it draws on the 4 highest levels of learning: application, analysis, synthesis, and evaluation, in addition to the core skills of knowledge and comprehension. Thinking Creatively with Calvin Taylor. An American professor of psychology, Calvin Taylor, is an important figure in the study of human creativity. His key idea was that many different kinds of skills and abilities exist, and that people who are gifted at one thing may not be much good at many others. Taylor claimed that typical intelligence tests measure only a small fraction of talents that have been identified, 10% at most. So he proposed that multiple talents should be evaluated in the classroom instead. He came up with the 9 talent areas, including some that he said were sidelined by the emphasis on traditional measures of talent. Alongside academic, he offers productive thinking, planning, communicating, forecasting, decision-making, implementing, human relations, and last but not least, discerning opportunities. Creativity goes into space. During the mid-1950s, in response to the Sputnik launch and other Cold War pressures, the United States government began to devote increased funding to the development of scientific talent. One beneficiary was Calvin Taylor's own Institute for Behavioral Research in Creativity, which held many summer creativity workshops for teachers. NASA funded studies there as part of a bid to find the ingredients that might indicate a future successful scientist or engineer. The research findings indicated a consistent pattern of independent thinking and working, and lots of self-confidence. Great news! Many people rated as low performers by the traditional measures rise to at least average level in one or other of the new talent areas. Taylor claimed that 1/3 of students would probably be highly gifted in at least one of the new talent areas. This new rating would thus increase their motivation and also allow efforts to be directed more constructively towards what people are good at, instead of uselessly at what people aren't good at. Maintaining motivation, knowledge, skills, and mindsets. The importance of maintaining a positive attitude in order to succeed while studying is well known. One study found that 2/3 of students who dropped out of school cited lack of motivation as a factor. Worse still, many of the 1/3 who remained in school were also demotivated. This section is about how mindsets, psychological attitudes, can determine levels of skill and even abilities. I hope that it helps you to get and keep yourself motivated on that climb to the top of the thinking pyramid, because it's up there that the most interesting things are happening. But being motivated is not quite as simple as it's sometimes made out to be, say by PE teachers chasing stragglers on a cross-country run. It's not enough always to be keen to do something, or even to make yourself do something. You have to be a realistic judge of your own abilities, and most importantly, about how to build upon them. Feeling your way to academic success. So, plenty of research suggests that motivation is crucial to success, but this sort of evidence points at a problem. Pause a moment to put your critical thinking hat on and jot down some possible weaknesses in the argument that boosting motivation is the key to success. You can read what I come up with at the end of this chapter. Nonetheless, solid research shows that motivation is a key indicator not only of school or academic success, but also for achievement in all areas of life. Hardly a surprise, of course. But motivation isn't something that gets taught at school or college, though a bit is introduced during training in the workplace. Remember, instead, most educational activity is firmly focused on delivering the curriculum and pedagogy, teaching methods. This approach is despite the fact that much research shows that psychological factors, such as motivation, often matter far more than so-called cognitive factors, such as verbal skills or even general intelligence, in terms of eventual results. Feelings matter. Feelings, say, about a student's own worth towards the school or college, or beliefs about job prospects. Perusing the paradoxical nature of praise. In the 1990s, as part of what was later called the self-esteem movement, some teachers attempted to instill more positive beliefs in their flocks by concentrating on making them feel good about themselves and their abilities, and their prospects of success. Unfortunately, the strategy intended to improve students' thinking rested on flawed thinking. The self-esteem movement assumed that assuring students that they were exceptional people, clever and talented, and so on, would not only make people feel positive about themselves, but also increase their motivation to work and do well too. In fact, it had the opposite effect. Praising students for their ability tends to produce a defensive response. Afterward, students want to rest on their laurels, so to speak. The study found that students who were praised like this were more likely afterward to try to avoid starting hard problems, because such problems seemed to carry a risk of failure, a risk of losing their laurels. Remember, praising abilities makes recipients think that they have a fixed level of intelligence, instead of them seeing learning as something they can nourish and developing their potential. Developing the necessary mindset. The reality is that in all areas of life, learning and achievement are about the willingness to explore new areas and to work persistently, steadily, and conscientiously. The paradox of praising someone's intelligence or skill levels is that it can discourage that person from progressing. Which is not to say that plenty of other ways exist to discourage people too, such as calling them stupid and useless. Tip: the mindset needed to achieve and be successful has two essential ingredients: a willingness to take on challenging tasks that provide opportunities to learn new things, instead of settling for easier tasks in your comfort zone. The psychological skills of persistence and self-control, instead of being the person who delivers a half-done project because the deadline clashed with a favorite TV show, or because last week's hot weather and fresh air seemed too enticing. Check out the nearby sidebar. Would you pass the marshmallow test for research in this area? Would you pass the marshmallow test? Walter Mischel and colleagues at Stanford University conducted a famous study in the 1970s to investigate the relationship of self-control to later academic achievement. Very young children from the university preschool were asked to wait for 15 minutes in a room with a little bell in it. In an apparently nice gesture, they were told that they could have marshmallows. But here's the catch. If they rang the bell to ask for their marshmallows, researchers would bring just one, albeit immediately. On the other hand, if they were patient and waited for the researcher to arrive, they'd be given 2 marshmallows. Children's responses varied greatly. Some rang the bell only seconds after the experimenter had left the room, while others waited the full 15 minutes. The second part of the study compared the achievements of the patient children some years later with the instant gratification children. The researchers used the results of the standard school leaving test as their measure and claimed that there was a striking correlation between the ability to wait for marshmallows at age 4 and the ability to solve verbal reasoning problems at age 11. The moral is, psychological self-control is an essential tool for later achievement. The good news is that most people can do something about it. Answers to Chapter 8's exercises. Here are the answers to this chapter's exercises. Dewey's Recipe for Education. My quick note would be this: knowledge is all about making connections. The rest of the material is interesting, but this is the key idea. It's been an exceptionally wet summer. I have the rainfall measurements, but the statement is still definitely my opinion. What makes something count as exceptional? Consider the background context of the claim. With which other towns or areas do I compare my figures, and over what time periods? Plenty of value judgments are lurking behind even this simple claim. Research on the problems of demotivation. I can see at least 3 things that should ring alarm bells for a critical reader with this kind of research. The claim that low motivation explains students dropping out of school. The significant finding to support this view would be low motivation among dropouts and high motivation among those who see their courses through. However, perhaps in their zeal to see low motivation everywhere, the researchers also identified evidence of low morale among those who stay in school, which undermines the idea that motivation is the key factor in whether a student stays on or drops out. A cause and effect law applies to this kind of claimed relationship. Students who struggle academically may become demoralized and drop out, instead of vice versa. The evidence offered is too vague to be persuasive. The researchers offer no names or dates for the survey, which is essentially a bit of hearsay, or these days, something read on the internet. Such research wouldn't stand up in a court of law. It doesn't really stand up in an essay